or we can create a new project. And when we create a new project, at the top there is a line, and this is a path, and we can set that path. Let's put it on our desktop, and let's call this Unity 101. In the body, in the main body, we see a series of Unity packages. And these are either standard assets that come with your initial download. They are packages you create yourself, or packages that you have purchased or downloaded from the asset store. And if you wanted them, you could say, I want a character controller and some glass refraction. I want particles and physics materials, a projector, and a mechanism example scenes. And then these will all be unstuffed when we create our project so that you have some building blocks to work with. But I don't want to start with these. I want to have a completely empty project. So let's say create project. Now don't be afraid about what you see next. It appears like Unity crashes. It hasn't. It's simply building these files to disk, and then once it's built these files to disk and it comes back, it then loads those files up. So we can now see that we have a Unity 101 on our desktop with our library and project settings and temp, and our assets directory is empty because we have no assets. The Ink Adept participant. What you do in your own home and what you give to your friends is up to you, as long as there's nothing too official about it. I can't tell you. I can't tell you what you and your friends want to do in the privacy of your own house, if that makes any sense. So we have this new project. All new projects come with nothing but a new scene. And we are in a new scene, and that new scene comes with nothing but a main camera. We'll talk about Blender tomorrow. Not today, unfortunately. So, but yes, we'll go into Blender tomorrow. So, why do we have a main camera? Why do all new scenes come with a main camera? Well, we could just decide to have nothing, new empty scene with nothing in it. But we need to have at least one point of view to render our scene. If we didn't have at least one camera, we could have all the game objects in the world. We don't know where we're rendering our scene from, and our users get nothing. We get a black screen. So every scene must have at least one main camera. Arguably, unless you were doing some audio thing, you could probably make an audio-only scene, and you wouldn't need a main camera. But that's the only reason why I can imagine you wouldn't want a main camera. So all new scenes come with a main camera. Now, this scene hasn't been saved. And there's two things that tell us this. There's two things that tell us that the scene hasn't been saved. The first one is we have no assets. The scene file must be saved in the assets directory, so we'll see it in our project view. And the scene file records all of the information about our scene. So the scene file is essentially like a Word document or a Photoshop texture or an Excel spreadsheet. Where we save the information about our scene is in the scene file. And that scene file has to be saved in the project. The other clue is up here, which it says untitled. When we're reading our header, we have the name of our current scene, our project, and our build target. We won't be building anything today, but let's just take a look if we had to change our build target. Let's say we change to web player and hit switch platforms. We can now see it says web player, or iOS. It says iPhone, iPod Touch, and iPad. So we see the scene, the project, and then our build target. So we'll go back to Mac, PC, and Linux standalone. And close, please. So the untitled implies to us that we haven't saved it. So let's go ahead and save that scene. And I'm going to save this in a new folder called underscore scenes. I like to, the underscore is completely unnecessary. I like to do it because I like to have my scene file sort to the top. And then in underscore scenes, I like to have, let's just call this one demo scene. So we now have our scenes directory, and there we have our demo scene. If we come back to our desktop, we can see in our assets directory, we now have our scenes folder with that demo scene.unity, and that's what's going to be saving our file. That's the file that's going to be saving all of the information about our game. Now we have to remember, save early, save often, save before you play. Unity is stable, Macs are stable, Windows stable, but they occasionally do crash. And random cosmic ray from outer space slams into our RAM, and somebody kicks the power out. And if we haven't saved our changes, those changes will be lost. The other thing, though, is we're writing our own code. We're assembling our own scenes. So we could do something crazy and suddenly push too many things to memory, where we ask it to suddenly instantiate a million things at once, and we max out something. We could write an infinite loop, and Unity hits that in our code, and it's perfectly happy to execute that infinite loop. And then we get the spinning beach ball or the rotating sand timer, and then we have no choice but to force quit our application. If we haven't saved our changes, those changes are lost. So remember, save early, save often, and save before you play. Also, a little bit of a rant. Find a way to save different versions, whether you're using, and Unity works with version control, whether you're using GitHub, whether you're using Dropbox. I have Time Machine. I also have Crash Plan. So that's saving stuff to probably someplace in Georgia. So it's an offsite backup system. I put some of the most important files into Dropbox. It's a little bit like braces and belts. So definitely find ways to save before you play, and save a version so that if something goes catastrophically wrong, that you can always go back and find some way to pick up where you left off. Because these aren't going to be emails to your friends. These aren't tweets. This is a project you can be working on for days, weeks, months, maybe years, and you don't want anything bad to happen to them. So game objects. Let's get into how we make some games. Our game objects are holders. Our game objects are containers. Game objects hold components. These game objects can hold any number of components. Game objects also hold other game objects. When holding other game objects, a parent-child relationship is created. The transforms of all of the game objects in a family are related to their immediate parent. And by holding other game objects, a game object can be used as a directory or folder for organization in the editor. So don't be afraid to use game objects for organizational purposes as well as mechanical ones. And we'll see that moving forward when we start making our game, that we can use game objects as a folder or directory. Now, game objects in detail. Where do we get a game object? From the game object menu. Shift Command or Shift Control N, or game object create empty. And this gives us a new empty game object. The first thing I think that's important to note is these new empty game objects aren't really empty. All new game objects have a header that includes its name and tag and other information. And all new game objects come with a transform. All game objects need to know where they are in our 3D volume. They must have a position, a rotation, and scale in space. Also, we can see that we have what looks like a bunch of arbitrary numbers inside our transform position. Why is that? Why do we have funny numbers there? Rotation came in at 0, so no rotation. Scale came in at 1 to 1. That makes sense, but position, bunch of funny numbers. Before we move on, I think we should have a moment to become honest with each other. We're all here to make games, that's true. But we all know we're here to make a fantasy role-playing game. We're not really here to make Angry Birds. We're not here to make Candy Crush. We're here to make a fantasy role-playing game. And everybody does have that somewhere underneath. We should be honest. We should bring it to the surface. We're not going to go around and ask everybody's name and how long it's been since they wanted to make a fantasy role-playing game. We don't have time for that. But it helps. So let's think about making our fantasy role-playing dungeon. And we know what a fantasy role-playing dungeon is. It's a series of maze-like corridors which are populated by thousands of treasure chests, and the gameplay is the character walks through the maze, opens the treasure chest, and takes out loot. Okay, now with that in mind, if we're in the far ends of some corridor, and we're going to be making a new treasure chest, and we start off with an empty game object, We don't want the game object to appear at origin. You really just want to make a mobile fantasy role-playing dungeon. Well, we can talk about the mobile part in Q&A. But if we're making this treasure chest and we create a new game object, we don't want it to appear at origin, which is way over far from where we're working. We want it to appear in front of us. So whenever we create a new empty game object, it appears at our current focus point in front of the camera. And if we look, this game object appeared bang on right in the middle of right in front of our camera. So wherever our camera happens to be and where it's pointing is where that new game object will appear. So this is why we get what appears to be an arbitrary position with no rotation and a scale of 1, is it's appeared directly in front of our camera. Now, if we had a random rotation and we had, say, some random size, and we want to fix some of these numbers, that's what this context-sensitive gear menu here is. It does a bunch of things, including you can reset the different channels, like reset scale, reset rotation, or if we had these arbitrary numbers, I'll come back here, Mr. Game Object, and our arbitrary rotation, and we wanted to reset everything, we can simply go to our little context-sensitive gear menu and say reset, and we now we're at origin with no rotation and a scale of 1. Then we can make sure we're selected and then do our frame selected or focus, and we're now looking at the origin point there. So that's 0, 0, 0 in X, Y, and Z, no rotation, scale of 1, the center of our scene right there. Yeah, Diablo for the TI-1000. Now that would be cool. So, or a little tiny digital watch, like I had back in 1970 something, which is kind of scary. The ones you had to hold the button down on. I think Douglas Adams had something to say about that. All right, enough. Let's get back to what we're doing. We've got this game object. It's now at origin. We can see that transform component defines the position, the rotation, and scale. And we create our game by attaching components to this empty game object. Components control our game object's behavior. Components are scripts when you boil them down. Many of the most basic components for us are pre-built, or many of the most basic components are pre-built for us by Unity, and these pre-built components have no visible or editable code. You can find these components by going to the component menu. You can see that we have mesh filters to hold our polygonal meshes, a mesh renderer to render them. We have effects like particle systems and trail and line renderers, lens flares, halos, projectors. Physics, we have a rigid body that allows the physics engine to work on a game object. Character controllers, we have collision volumes in different shapes, boxes and spheres, and we can use an arbitrary mesh. We've got cloth, joints, navigation. We have simple AI navigation that we can work with. We have audio, audio listeners, sources, zones, and filters. Rendering, like cameras, skyboxes, flare layers, UI layers, lights and light probe groups, occlusion areas, GUI text and textures, and then miscellaneous here at the end. We have an animator, which works with our Mechanim state animation state machine. Animation, we can animate any curve in the game. Network view for multiplayer games, and wind zones, they bend our grass, our trees, our particle systems. And if we write our own scripts, we'll get a new tab at the bottom that says scripts. And with one line of code, which we can talk about in Q&A, we can rearrange and reorder this entire menu for our scripts. We can put our custom scripts into any tab name we want. I heard that some users use custom meshes or something where you can make your own mesh. Yes, meshes all come from a third-party solution. You can make meshes, and we'll talk about this tomorrow in code inside Unity, but primarily you're going to make your mesh inside a mesh modeling application like Max or Modo or Maya, Blender. One of the main, pretty much any 3D package we support, all the main ones we support, or you can also support FBX files directly. There are some third-party add-ons that you can get from the asset store that allow you to do mesh modeling inside Unity, but they're certainly not as robust as the big boys that we can get as standalone applications. And we can talk about that in Q&A, and we'll definitely look at them tomorrow in 102. And remember that Unity is essentially that editor like Final Cut. You go somewhere to shoot your film, and you go somewhere else to get your music, and you get somewhere else to do your titles, and you bring them all together in an editor. Well, same thing here. This is the editor, and so we bring our mesh models in, and we bring our code in, and we bring in our sounds, and then we build it all together into our game here in the editor. So let's take a look at this game object, and let's attach a new component to it. The way we attach a component is we just pick one from the component menu. We can just pick a light, or we can come here to the Add Component button, and that gives us the same list. And essentially, if you look at it, we have Assets Create, which is the same as Project Create here. We could create a new asset. Inside our scene, we can go to Game Object, Create Other, or inside our hierarchy, we can create other, same menu. Same with that game object, we can add a component using the component menu, or we can just hit add component inside the editor, and we can add, say, a light. Now, we've got a game object that behaves like a light. If we look at the component, the way you read the component, it has a header. The header has a turn down arrow, but you don't have to click the arrow. You can click anywhere in the header. It has an icon to remind us what this is, the transform X, Y, and Z, a light. Whether that component is enabled, if it's something you can turn on and off, you can enable and disable that component, and then the component type, which is here, light. Now, on the left-hand side are properties, and on the right-hand side are their associated values. So you can do things like reduce the range, or increase the range of the light. You can change the color, which coincidentally, if you look at the gizmo, it'll change here, the gizmo as well, so you can change the color of the light. You can add textures and shadow types and halos, and so this is the way that you control the behavior of this component, is by changing the values on the exposed properties. If we look at our main camera, look at the main camera, please. Thank you. If we look at the main camera, we're starting to see that same pattern. We've got the header. We've got a transform, same as our game object. And then there's a camera component, and that has properties down the left-hand side and values down the right. We could change the background color to being anything we want it to be. We could change the information about how this camera behaves by changing the values on its properties. At the bottom are some additional components, but these, even if we turn them down, we don't see any properties. Well, that's because these particular components only do one thing, and there's nothing for us to have that we can manipulate or change or have control over. The audio listener simply listens for audio. The GUI layer and the flare layer are simply enabled by this component being attached. Now you can enable or disable this these components, but there's no settings that you can change on them. Now let's take a look at our game object here. It has a light attached, so we can change its name. You can change it up here. We can change this to being anything we want it to be. Watermelon. We can change it in the hierarchy as well. Hit the return key so we can edit it or double click slowly. Captain Kirk. Take your pick. But let's go ahead and call it light. We don't have to call it light because it could have as many different components, but this tells us something about this game object and its components that gives us a hint as to what we want to do with this. So we now have our light component. We have our main camera. Let's say we wanted to create a sphere. Well, we could create a new empty game object. And then we could add a mesh filter to hold a sphere mesh. We could then put a sphere mesh in it. We could then add a physics sphere collider. And we'll explain this in a second if you're curious. This is called floating point decimal error. Basically, numbers seem to drift by a very, very small amount. It is an inevitable side effect of computers, which are essentially in binary and trying to deal with digital numbers. We could add a mesh renderer to render that mesh. We can see, we've got a little dot down there. We could add a new material. We could add just the default diffuse material. Very useful. Interesting. We've got a sphere now, frame selected in on it. Let's call this this new game object. Let's call this ours. Our. I believe I can learn how to type. Our sphere. That's our sphere. Not too bad, but if I had to do this every single time, I might begin to pull my hair out, adding all these different components. Well, let's take a look at what Unity's done for us. It's given us a game object. These are pre-built game objects. It gives us a sphere as one of the options. And let's reset this to origin and take a look at the difference between their sphere and our sphere. Our sphere and their sphere. The only difference is the name. So we can build up our game objects one component at a time, or we can look at the Create menu and see if they have a pre-built game object. And these pre-built game objects are essentially an empty game object with the components pre-attached and the values preset on these components. So how do we get this little black dot going on here? Remember we said it was all of the different game objects and how they act and interact with each other that give us our game and gameplay? Well, the camera is rendering the scene, and it finds out about the sphere by looking at all the components. So the main camera looks at the sphere game object. The sphere game object has the mesh renderer. The mesh renderer is looking at the mesh filter, which has the sphere mesh. Remember, the mesh is the little blue lines. And then it feeds that sphere mesh into the mesh renderer. It uses this default diffuse material to give it a surface. And then that information is passed to the camera. The camera then looks at its own settings, including things like its field of view. Let me back out here so you can see what I'm doing. What's the field of view? How does that change? Looking at its transform position. And all of the settings on the camera component and on the camera's transform component, and comparing that to the transform component of the sphere, and it's rendering a little black dot. It's even doing more. That main camera is not only looking at the sphere and its mesh filter and its mesh renderer and its transform, and comparing it to the transform of the main camera and all of the components on the main camera, and all of the properties on the components. It's also looking at the light and looking at the light's transform and all the light's properties. And the reason that we don't see anything here is because that light is buried inside our sphere. Now, if we lift up and change the value of our transform, we can see how it's changing the lighting in our scene. So every frame, it's going to look at the relationship of the transform. So it's looking at the transform of the light and the transform of the sphere and the transform of the main camera to figure out how to render our scene. And we can see as we move it, it's changing what our scene looks like. So let's hit save, let's hit play. Nothing happens. Nothing happens because we have not asked anything to do anything more than we see. This is doing everything we expect. Our light is lighting the sphere is just sitting there, and the camera is rendering it to our players. Yeah, you can enable snapping. We'll talk about that a little bit further on in today's lesson. We'll talk about the couple. There's at least two different ways you can do snapping. Ignoring the fact that you can just set the values by hand here in the transform. So if we want more gameplay, more complexity, we either need more components on our game objects or more game objects or both. So if we take our sphere and we add a new component, we add physics rigid body, we've now added a new component. We now have mass, we have drag, we use gravity, we hit save, we hit play. and the ball now falls into the void. Let's turn off maximize on play so we can see this. I'll back out a little bit. Let's hit save, let's hit play, and we can see that that ball is now falling into the void of our 3D scene. So ignoring the render path, which every frame that camera is looking at the sphere and its mesh filter and mesh renderer, what we have here is every frame, the rigid body is dealing with the physics engine, and that the rigid body is using the physics engine for information and affecting the transform. So every frame, it's using gravity, which is minus 9.81 meters per second squared. And we hit play, and we can see that every frame, it's adding more to its rigid body velocity, which we don't see, it's an internal value. And then it's applying that change to the transform position Y, and it's dropping in our scene. And this will continue to happen forever because our acceleration doesn't really have a point. So it will continue to accelerate. There's no air resistance. It'll just go and go and go and go until we stop the game. If we want more complexity, we can also create new game objects. Let's add a plane, put that to origin as well. And we now have a plane. Our sphere is buried into it, so let's lift up our sphere a few units. Let's hit save, and now let's hit play. And the ball comes to rest on the plane. And this is interesting because we have that rigid body on our sphere that's always trying to make it fall under gravity. But at the same time, the physics engine is looking at the collider volumes. And remember, the collider volumes are the green cages. So we're looking at the green cage around the outside. We turn it off. There's no collision resistance. It falls through the plane. So every frame, bonk, this green collider is on the plane. Now we have to see the mesh collider, which is sharing the same mesh as the mesh filter. Let's turn off the mesh renderer. And this allows us to see the collision plane that we're resting on. So every frame, the physics engine is trying to add force against the ball, trying to make that transform position Y get lower, subtract some value from transform position Y. And every frame, that means the plane is trying to penetrate the sphere. And the physics collision engine will not allow that sphere to have anything inside it. It will not allow anything to penetrate its collision volume. So that means the sphere is forced to come to rest on top of that plane. So let's turn that mesh renderer back on again. So this is the architecture we're getting used to, which is that we've got our player game object, falls down under gravity. He has a rigid body, or she has a rigid body, and she doesn't fall through the plane. The plane doesn't have a rigid body. It's static geometry. This is the plane is the equivalent of our terrain, or it's the floor of our dungeon, of our castle. Our player moves along it or slides along the surface of it, and is interacting with that. He can jump off a ledge and it will come to land on the next surface, come to the edge of a ledge, whoop, and falls off into the void. So it's that action-reaction between all of our game objects. The more game objects we have, the more complex game objects we have, the more they interact with each other, the more complex our game and gameplay. Can you make it bounce? Yes, absolutely. Can you make the sphere only collide with certain objects? Yes, you can do that with layers. That's partly what the layers are for. You can add more layers, and then you can talk about layer-based collision detection. Can you make it bounce? Yes, you can. That's physics material that goes into the collider. We can talk about that in Q&A. Is it possible with scripting? Yeah, both are possible with scripting, which will probably be covered in another section. Yes, and you can also do some things where you can create a physics material, and you can make that bouncy, and you apply it to the collider, and then this will bounce. So let's go ahead and take a break. And break. And let's come back at by my clock 21:15. And then we'll move on to prefabs. So, and if you have some questions, throw them out in the chat channel. I'll be away from the keyboard for a little bit, and then I'll come back, but I'll try to get them answered. So ignore what I'm doing here, which is I'm going to create a text. Boop. And it's going to say break back at boop 21:15, and then center. All right, welcome back. Sorry about that. If there was a problem with the email, those are usually sent out by Adobe Connect. I'll have to double check that, why you'd end up with two. Whoa, what's going on with my iPad? Come back, Mr. iPad. Sorry, hold on. What's going on with you? Silly thing. All right. Oh, and then I've now completely buggered up my... There we go. So, we have these game objects and their attached components. And we've seen how convenient it is to be able to create game objects directly in our scene with our pre-built components and our pre-attached components and preset values. Yeah, I'll have to check that. I mean, I don't understand how we had that there was a wrong room. Actually, let me just quickly double check something, because if there are people waiting at the wrong room, that would be a bad thing. Let me just go ahead and quickly do one quick check, because I get those. I don't read them when they come in, because I get them as well. Oh, you are correct. There are two. I'm going to leave this room and be right back, just in case there are people waiting for the other room. And don't go anywhere. We're doing good for time. So let me just load up the launch page, and then I'll leave so that you guys can see if I can run two concurrently. Huh. Hold on a second. No, good. There doesn't seem to be anybody waiting. That's all right. Sorry about that. Cool. All right. Back to you guys. I didn't know I could run two rooms at the same time. How nice. You need to make it bounce. You need to make a physic material. Would you create a physic material? Learn how to spell. There we go. Physic material, and then set its settings, and then you attach it into the collider's material section. So we've seen how Unity gives us these pre-built game objects. We can see that sphere, and it's very convenient if we need an extra sphere. But how can we make our own pre-built game objects? Because if we end up making, say we want to make that treasure chest, and if we have to put 1,000 treasure chests in, we have to make a new game object, and then we have to attach a mesh filter to hold our chest mesh, and then we have to mesh renderer to render it, and then our materials, and then our logic has to be a script. And we had to rebuild this every time for 1,000 objects. This would become to be a real pain. Well, Unity luckily gives us something called a prefab. And a prefab is an asset, and we can see that. Let me just quick that. We can see this in our folder. We now have our new prefab.prefab, which is an asset in our assets directory. And this will hold a template or a blueprint of a game object or game object family. And the way that we use these is we're not going to create a treasure chest today, but let's create something that is the analogy of a treasure chest. So let's create a pre-made capsule. And I know that this unit that this object is 2 units tall and 1 by 1, because all of Unity's primitives are 1 by 1 by 1 or 1 by 1 by 2. And so because of that, I know I can lift that up by 1 unit, and I'm resting on the plane. So there's my capsule. Let's create another game object called a particle system. And then we're not going to talk about how to use particle systems, but if you look over my shoulder, you can get a kind of idea of what's going to go on. I'm going to reduce the lifetime down to 1 and the start speed down to 1, so it's a little slower, size to about 1/2, and then I'm going to change the shape from a cone to a sphere. And this is just so it's a little less obtrusive there. And then, oops, to a sphere, yep. Size to 0.5. And then I'm going to parent that, make that a child object to our capsule, and then I'm going to reset the transform. And you'll notice it's not going to snap to game origin, but it's going to snap to the center of its parent, which is the capsule there. Now, if I wanted to make another one, let's also, while we're here, to the capsule, let's add a physics rigid body. Let's just give it some complications here. So if I wanted to make another capsule, I'd have to create another capsule, add another rigid body, make a new particle system, change all the values, parent it, reset it, all of that. Real pain. But I can take this complex game object and save it here in my prefab. And now I'm going to name this, remember our watermelon rule? Can name this anything I want it to be, but heck, let's name this capsule so that it seems to make sense. And then once I have this prefab, I can drag it into my scene as many times as I want. So this means I can also drag it into my hierarchy, in which case we'll see it there in the same location. And so now if I want to make my treasure chest, I only need to make one. I can make a new game object. I can add its mesh filter, its mesh renderer. I can then add the logic. I can give it its textures. And then I make a prefab out of it, and I can put this into my game anywhere I want to. So I can lay out my 1,000 chests all throughout my dungeon level. And as a matter of fact, since it's an asset, I can put it on any scene in my game. So let's remove these extra ones. And then let's take this first one we put down, and then I'm going to go into top-down mode. Notice that as I play with my gizmo, I can go to different locations. And then either by touching the center cube or by touching the label, I can go into isometric or orthographic mode where I have no perspective. So let's take this capsule, and then I'm going to duplicate it and then move it. And then I'm going to duplicate this again and move it. Now, the savvy participant is going, hold on a second here. If you can duplicate and this prefab, why didn't we just simply duplicate that original capsule or our original treasure chest? Well, there's a problem with that. If I duplicate my sphere, I now have two spheres. Now, if I want to make a change, let's say remove the sphere move the sphere collider, and I can change its rotation, and then I can change its scale on one axis and rotate it around on another one, is that I'm not making any change I make has no effect on that original sphere. This is simply being made, making changes to this new sphere, and it has no effect on that original sphere. That's not true of our prefabs. Our prefabs have a lot of control with each other because these are now instances of this asset that I can start to make changes to the asset, or I can make changes to the instances, and they will be related to each other. So let's see this in action. If we take a look at one of these instances, we can see that we now have a new prefab line. Select, revert, and apply. And I can use the select button. It's just pretty much a helper button. So if I've got a complex game and I find an instance and I want to find the asset, I simply say, excuse me, they're not supposed to do that. So you can simply say, find that asset, and you can see there I am in that with the capsule. I hit select, and it finds the asset there in my project. So a little bit of a helper button. The other two actually do something important. I can make changes to the instance. So let's add a new component. So I've got this instance here. Let's add a component. Let's add a light. It's pretty obvious what goes on. See, whoop, there's a light. Let me undo that. Go ahead and do that again where we can see that. Let's add our rendering, our light. You can see now there's a light on that. I can decide that was a mistake. And I can hit the revert button. And when I hit the revert button, it's going to change all of the values on all of the components and make it a complete copy of the master asset, with one exception: transform position. The only thing that will not be reset is transform position, because we've placed them in the location we want. We wouldn't want to, when we're reverting, also have it snap to some fictitious location. So, but a rotation, scale, and then all of the components and all of their properties will be made an exact duplicate when we hit revert. On the other hand, if I like what I've done, and I like that change, and I made a change to this instance, I can hit apply. Apply applies that change to the prefab asset and it immediately rolls down to all of the instances. So now let's think about this in the context of our treasure chest. So we've made our treasure chest, we've populated it around the game board, and then either we wake up and go, I wish I had made that lid open up. I wish I'd been able to see inside and see the gold. When we click on it, the lid opens up, we see the gold, light comes streaming out, and we can hear the choir of angels sing. More likely, we're going to be working somewhere and the producer comes to us and says, dude, you forgot to animate the chest. In which case we suddenly think, oh no, I've got 1,000 instances out there. I have to make 1,000 little changes. You don't. You simply make one change to one treasure chest until that treasure chest is working perfectly, and then you hit apply. And it applies it to the asset, and then it applies it to all of the instances in your scene, and the instances in every scene in your game suddenly adopt this new change. But it's a little bit like the Ginsu knife and the bamboo steamer. There's more, but wait, there's more. If you have your prefab asset, you can change any of the associated values on any of the exposed properties. So we can do things like change the color. Whoop. And now I'm doing this on the asset, and instantly I don't have to hit apply. It doesn't make any changes to my scene. My scene is not suddenly tagged as needing to be saved because I've done this to the asset. I can change things like the range, and you can see all of them have changed their range. And think of this now in the context of our treasure chest. So if we suddenly need to come along and someone says, we really like your treasure chest, but the color of the light is just wrong. We want it's the wrong shade of pinky russet. We want a more mauvey shade of pinky russet. So you can simply come to your master asset, and then you can make a change to that master asset, and suddenly the light streaming out of your treasure chest is different. You can even cut a tin can with it. Yes, you can. Is it possible for a prefab to contain another prefab? Yes, but at this stage, there is a certain limit to how much changes you can make. You can have nested prefabs, but unfortunately, at this point, my perfect analogy of what I would like these to do is, let's say you had two spaceships, the enemy spaceship and the player's spaceships, and they were prefabs. And in them they shared the engine prefab, so that you could only make a change to the engines and it would change off of both prefabs. It doesn't work that way, unfortunately. Because of the way that the nature of prefabs work is that ultimately you can put prefabs into another prefab, but then once you save it, it loses that connection to its prefab asset. So not the perfect nested prefab yet. The engineers are aware of it, but it's a complicated issue that is surprisingly difficult under this architecture to get done. If you don't hit apply, we're going to get to what happens if you don't hit apply in just a second. So let's say you don't want to hit apply. Let's say you want to make a change. If you want an original object, let's take this lead capsule and let's change its light to, say, from magenta to cyan. And so now it's a sort of a blue light there with everyone else being magenta. It's a cyan light. And we can see, if I toggle back and forth, look at the color title. Notice that on the one that we have, it's bold. That means this value has been changed, and it's what's called as overridden. Now, if I were to hit apply at this point, all of the capsules and the asset would go cyan. If I hit revert, it's going to go back to magenta. But I can leave it in this half-finished state where we've neither apply nor revert, and it is overridden. We've changed and overridden that value. We haven't broken the connection to the prefab asset. Now, if I change the color, let's change all of the color here to blue, and you can see, let's make these a little bit bigger. You can see that the value of all of the other lights have gone blue. It's sort of hard to see because the cyan's overriding them, but they're all blue, and it hasn't changed the cyan light. But you can see that as I'm changing the range, that the range is changing. So we haven't broken the connection with that capsule with the prefab. We've simply overridden the value of color but all of the other ones will continue to change. So intensity and range and all of that sort of thing will still be connected. In the context of our fantasy role-playing game, let's think of this in the context of a monster. This means you could have your orc prefab, and you could spawn as many first-level orcs as you wanted. But now we've exposed level as one of our public properties here. So then you create another orc, and it now has a level of 2. So out of the same prefab, you now have a second level orc. And that second level orc could have twice the attack and twice the hit points, twice the defense power, and if you're even clever enough, it could, on the start of the game, go and find a different set of armor. All out of the same prefab. So, prefabs, very useful, very helpful. The question I have now is that we're dealing with these pre-made game objects and pre-built components. Can we make a game using nothing but pre-made game objects and pre-built components? Let's give it a shot. So let's take this. One of the problems that you have is that you can create, you can have a prefab, and you can have an instance, and you can make it a prefab. You can make it a broken prefab, and we talk about this when we make the game. So it will be prefab missing, but you can't make it not a prefab. This will continue to operate at its last known state. So it's not broken and just fails to work. It will continue to operate at its last known state, but it knows that it is a prefab object, that it can't find its original asset. So you have to be careful that you don't do this just for fun. Only prefab the things you want to be a prefab, because you can't really undo it once it's done. So you can break the connection, but you don't turn it back into a non-prefab game object. It will always be an instance of an object that doesn't exist. A bit weird, but that's what happens. So let's take this plane, let's call it ground, and let's duplicate it, and let's call this one slope. So I want to move this and turn it into a slope, my little slope game object. So I can grab it by its handle. I can move it by its transform. Same thing with the rotation. I can swap over my gizmo to the rotation, and I can grab the an axis in the gizmo. I can grab the title. Notice that when I'm grabbing the title, and you can do this for most things, you can see I've got the two little arrows, and then I can move that smoothly back and forth. Or I can type in a number directly, so I can make it exactly 45 degrees. If I want to line these two up, I can then go back into my manipulate, and I can go ahead and move that and try to get these two to line up. And then what I was changing is the global and local. Notice that when I go to local, I'm in my local orientation. When I hit global, I'm in global orientation. So I can move this in local space, or I can move this in global space, basically lined with the world axes or lined with the axes of the rotation of the object. And I can come pretty close using the two of these. But speaking of snapping, there are two types of snapping. First type I'd like to talk about is vertex snapping. If I hold down the V key, notice that when I hover, I'm just hovering my mouse, it's hovering over and snapping to a vertex on this mesh. Now, a vertex is the point from which we draw our lines or edges. And what vertex snapping does is it allows me to pick a vertex. I'm just going to hover over, and then I click on one, and then I can snap to the vertex, to another vertex, anywhere on another mesh. And this includes the rather complex vertices of our sphere or our capsule, or since these two objects are identical, I know I can snap it to this outer corner, and this is a perfect weld. The other snapping is if you hold down the Control or Command key, it will snap in Game World as you just grab the transform in even increments, and you can set that up in your edit snap settings. And currently it's just set to 1 unit in each direction. So if you hold down the Command or Control key, Command on Mac, Control on Windows, it'll snap. And this is true for everything. You can snap your rotation and you can, and it's by a small amount. You can also snap your scale. You can notice the scale X is moving in exact 0.1s. So now we've got our slope. Let's grab our sphere. Let's go back to move, and I'm going to grab it on a plane so I don't move left and right. I only move forward and back and up and down. So I'm moving on the YZ plane. Let's put it up there. Now, the savvy participant is going to get an idea of what we're doing here for our little game. Now, before we get started, we've got a problem with our main cameras. Our main camera is down here and it doesn't see very much. So let's move the main camera around. Our main camera is simply a game object. So you grab it by its transform. So you can move it into a position here next to the game board, and you can lift it up. And then we want to rotate it, hit the E key, get to our rotate gizmo, rotate it around, rotate down. W key for move. We're in local space, so we could move that up, move that back. Rotate around, but let's move it around in global space so that we're rotating relatively evenly. Not bad. I'm sure that I could get a good look on my game board, but I think I have more control over my scene view camera with my extra buttons than I do with my game view camera. So there's a little quick trick, which is that I can move my scene view camera around until I have a good view on my game view, on my game board. So if I say like this looks good, I can then grab my main camera, go to game object and say align with view. And align with view will snap the game object, in this case our main camera, and align it exactly with my scene view camera. So if I don't really like that view, I can move it around, punch in a little bit, try it again. And then if this looks good, I'm done. The other ones here are align view to selected, so you can pick an object out of the scene, and then you can say, I want to align view to selected. And now my scene view is now lined up with this lead capsule, or I want to go back. I can pick the main camera, align view to selected, and then move to view is simply grab an object, and as opposed to the opposite of frame selected, where you move the camera so that it's in the focus point, if you say move to view, it grabs the object and pulls it to you. So let's say we wanted to put down a treasure chest and we put it in the wrong place. Just select it from the hierarchy and pull it to your current view. So let's save this. Let's hit play. Ball rolls down. Boom. And doesn't do very much at all. Why is that? Well, that's because if we look at our rigid body component on the capsules, they have a mass of 1, and our sphere has a mass of 1, which means we've got 1 mass on the sphere moving into 1 mass of the pins. They do something, but not very much. What I want to show is the advantage of working inside the editor. If I want to make a change, I can simply change the rigid body on my sphere. I can change its value to some number, more than 10. Let's hit save. Let's hit play. And you can see I'm instantly testing that change. I changed it to 13. It now has a mass of 13, and it does significantly more to the pins because it's got a much higher mass. Now, the if I want to make another change, I can just grab it again, just crank it all the way up there, save, almost 100, play, excuse me, play, and now we're testing out on nearly 100 times the mass. So we're not having to go into a scripting environment. We're not having to make changes on a script. We've exposed the values we want to change, so we have access to them here inside the editor. We simply make our changes, we hit save, we hit play, and we're testing the change. So that's how quick you can make changes inside the editor. You can put left-right controls on the sphere. We'll do that later today. But this comes to my next bit, which is, have we made a game? And I would argue we have not. I argue that pre-made game objects and these pre-built components don't make a game and don't give us gameplay. Pre-made game objects and pre-built components give us the building blocks for making our games. We have lights, we have cameras, we have colliders, we have a physics engine, we have particle systems, we render things. But these pre-built game objects don't make a game in gameplay. The developer must write simple behaviors for their game objects using scripting. So what is scripting? Scripts tell our game objects how to behave. And it's all those scripts and all those game objects that make our game and gameplay. How does scripting work? Scripts use logic. Scripting uses logic, not maths, to drive the code pre-built into Unity. And it's the code that's pre-built into Unity that is the Unity game engine that's access to something we call the API, or Application Programming Interface. The code that we drive, as I said, you drive it through the API, and the API can be found in the scripting reference, but we'll find that we'll talk about that in just a moment. Now, scripts are written in a special language that Unity can understand, and it's through one of the languages that Unity can understand that you will talk with Unity. So speaking of the conversation, what languages are available to developers to talk to Unity? There are three. There is Unity's version of JavaScript. Now, this is not the JavaScript that people use to write web pages. If you Google JavaScript, you're going to get a similar but different language. Unity's JavaScript is pretty much C# with JavaScript syntax. There is C#. You can, it's a common scripting language. You Google C#, you'll get C#. You can code in C#. Then there's Boo, which is a Python-inspired scripting language. Now, all three languages are object-oriented scripting languages. The two most common languages in use today are Unity's version of JavaScript and C#. Both of these common languages are nearly identical. Unity's version of JavaScript may be easier to begin with. Many people with no coding experience find that Unity's version of JavaScript is much more comfortable. But people with coding experience often find that C# is more exact, but it is a more pedantic language, and as such, it can be intimidating to new users. That being said, we are going to be teaching in C# today. Like any language, these scripting languages have a syntax and have parts of speech, as it were. And the primary parts of speech that we are going to be dealing with today are variables, functions, and classes. There are many other of these sort of parts of speech, but we aren't going to be talking to them. We're going to be teaching them today. We're going to be talking about them today. As a matter of fact, we're going to barely touch on classes. We're going to kind of tip our hat in the direction of classes and then move on. Now, the primary use of each of these little parts of speech is variables. They hold values and objects or references to them. Functions are collections of code that compare and manipulate variables. And classes wrap collections of variables and functions together for use and reuse later. Now, scripting is primarily comparing things or objects and their current states and values, and based on logic, not maths, determining an outcome or resolution. So, if you can walk into a store and say, if I had enough money, I would buy a sandwich, you can write a script. The standard ref docs are written in all three languages usually. And I'll show you how to use those in a moment, because we will we'll be looking at the documentation as we move forward. But we're going to be using C#. So if you can walk into a store and say, if I had enough money, you would buy a sandwich. I would buy a sandwich. That's good. You can write a script. But if you can walk into a store and say, if I had enough money, I would buy a sandwich, or else I would have to leave the store, then you reach into your pocket, check to see whether you have any money. And if you do, you buy that sandwich. If not, you leave. You can definitely write a script. Now, scripts are text assets. They're simply text files. And you could edit them in Notepad. You could edit them in TextEdit. You could probably even edit them in Word. Just make sure you don't save it as a Word doc. And we create them in our project view using the Create menu, and we're going to create a C# script. Let's name this one Demo Script. And we can see when we inspect it, when we're looking in the inspector, we're seeing a quick preview. It's not editable. This just shows, it's a limited preview. It shows the first few lines of code, and this gives us an idea if we're looking at the correct script. If we look at our desktop, we can see that we now have this demo script.cs for C#, JS for JavaScript, but they are ultimately just text files. The extender just gives us more information about where we should open these up and what particular language we should be coding in. We can open these, and we'll be opening these in a companion program called MonoDevelop. Now, what is MonoDevelop? MonoDevelop is essentially a very powerful text editor. Like I said, you could use Notepad, you could use TextEdit, but we want to be in a developer's environment because it gives us some great helping tools. Beyond the subject of what we're doing today, you could attach an instance of Unity to MonoDevelop, and you could use it to step through your game one line at a time and debug it. There is also, you can use any other developer's environment. You could use Sublime Text. You could use Visual Studio. There is a third-party add-on that allows you to do debugging to attach an instance of Unity to Visual Studio for debugging, but we're going to be using MonoDevelop today. You can see that it also highlights our code with different colors. This allows us to read it a little bit more easily. Also, when we make mistakes, it will give us a little red line saying it thinks that we're making a mistake. And then if we start to write something, it's going to give us a suggestion of what else we could write to complete our code for us, which is very, very useful. Can you use multiple languages for one game? Yes, I don't recommend it. And when you compile, you can have two scripts that don't talk to each other side by side, different languages, no problem. If you've got two scripts and one of them needs to talk to another script, all languages must go one direction. You have to compile one language first. So if you have a JavaScript that talks to a C#, you need to make sure the C# scripts compile first, and that's fine. If you've got a JavaScript that needs to talk to C# script and a C# script that needs to talk to JavaScript, you cannot compile one of the languages first, and therefore you can't use those multiple languages. Why is it not integrated into the editor in Unity? Generally the same reason why we don't integrate mesh modeling, we don't integrate painting, we don't integrate many of the other things that you could do inside Unity is that other applications do this better. And it's sort of a different workhorse. There are third-party add-ons that you can get. There's at least 2 on the asset store that will allow you to edit your scripts inside Unity. So if you're interested, you can go onto the asset store and buy one of the inside editors. I think it's UNIDE, and also Script Editor 2. And I've not used UNIDE, but I've used Script Editor 2, and it's a good application. So definitely take a look at the 2 of them if you want to stay inside Unity. But most people prefer to be in a proper developer's environment. Yes, and you can have your choice. You can choose to be in Visual Studio. Yeah, and no need to reinvent the wheel. That is correct. Is it possible to set breakpoints in this code? Yes, you can. Inside Unity, you can use the debug class, and you can make a debug.break, and it only works on a frame-by-frame level. But if you attach an instance of Unity to MonoDevelop or using a third-party plugin to Visual Studio, you can put in break points, and you can look at it line by line in a proper debugging situation. Not in the case, Seneth89, not in today's lesson, but maybe we will get something up on the site, and also it's I can show you where you can give us some recommendations, and we can show you how to do that. Yeah, Script Inspector. I like Script Inspector too. It's he's put in some good work in that. I can't wait until we can get proper code completion. But I do a lot of work inside Script Inspector too, just to keep it limited, especially fast stuff. Really nice. But I originally coded in a text editor, not an IDE, so I'm used to writing without code completion. So let's go ahead and talk about our scripts today. What do we want to do? Well, first, let's talk about how Unity works. Unity works in a giant loop. Unity reads all of the relevant code on all of your enabled components, on all of your active game objects, performs all of the logical interactions, and then uses that to render a frame. Then it goes back to the top of your game and reads all of the relevant code and all of the enabled components and all of the active game objects, and renders another frame. And it does this several times a second. And you need, if you think about film and television, if you've got the old hand crank cameras at 15 frames a second, you've got modern movies. If you're not Peter Jackson, that is, running at 24 frames a second. Then you've got European television, 25 frames a second. North American television at 29.9573 frames a second. And so you want your game to be working the same sort of way, where you want to be 15, 30, 60 frames a second. And so Unity needs to read all of your code that many times. And also there are times when you want to do something that is involved in that game loop or that frame. So let's say we're looking for input from the keyboard from the player. We don't want to do that intermittently. We want to do that every frame or every game loop. We want to apply that input as movement to our force, to our game object. We want to do that every frame. And Unity luckily gives us something to do that. It's update, function update is called once per frame just before rendering the frame. And this is where most of our game logic is going to go. If I'm wrong, if you create the script through Unity, it adds basic skeleton, whereas if you do it manually, yeah, I mean, the basic skeleton, you can see that this is a pre-made script. And if you really were to start in some scripting environments, you'd start off looking like this. Honestly, after a few of these, you start to get familiar with it. You need to have some namespaces. You need to create a class. That class needs to derive from mono behavior, and it needs to have the same name as the script. Update is basically where we interact with the game loop, M. Night, rather than the game loop itself. So the game loop is running along, and then as part of the game loop, every frame, every loop, it will look at all of the enabled components on all the active game objects and run the code that's inside update, if that makes sense. So what do we want to do? Let's take a back look at Unity. I want to grab this light object here, and I want to look at the light component, and I want to turn it on and off. And I turn it on and off by affecting its enabled state. Now, that's not to be confused with the active state of the game object. You can see the active state's turning on and off everything on the game object. The enabled state only turns on and off this component. If we had something that was more complicated, you can see I can enable or disable the audio listener, enable or disable the UI layer, enable or disable the camera. But if I turn the game object off, it makes everything inactive. So I want to grab the light component. I want to leave the game object active. I just want to turn on and off the light with its enabled state here. And the way I do that is, remember, this is a logical language. It's a new language. So I want to say if the input from my player, and I can do that with asking for input, if the input from my player is the key, and I use this with something called getKey, and it's the key called space. So if I hold down the space bar, this will return true. So if input getKey space, if I'm holding down the space bar, then what happens? I want my lights enabled component to be true. And we're dealing with what's called a Boolean state, which allows true and false. Some people are used to 1 and 0, or on and off. But our Boolean state only allows true and false. And then also, to make things even more confusing, it's shortened in C# to bool, which we'll see that in a minute. So if input getKey space, if I'm holding down the space bar, then my light, and the reason this works, and we'll see this going forward, is that this is a shorthand that Unity gives me to the light component on the same game object as my script, and my script will go down here. And the case-sensitive language, so there is a difference between light, which is a shorthand for the light component on the same game object as the script, light with a capital L, which is a type, which defines the type of light, and forgetting to let go of the caps lock key in time, or the caps key, which then gives us a new name because it's different. So any of this change in capitalization gives us a new name, and you could use that legitimately for a name. It just might be confusing. And so the lowercase light is a shorthand, so I can grab that light. Remember, if I had enough money, I would buy that sandwich, or else I would have to leave the store. If input get key space, if I'm holding down the space bar, the light's enabled state is true, or else the light's enabled state is false. So we save this, we come back to Unity, and we look for errors. When we're done writing scripts, the first thing we do is, did we make the right script? Did we make an error? We can see the error in the footer. I don't see one today. And we can also check our console. So we are error-free. What a pity. Let's make an error. Let's remove that final semicolon. We can see that MonoDevelop is already saying, I think there's a problem here. Now, what is that semicolon? Well, that's like if I was to write in English, this is a statement. I'd end it with a full stop or a period. Well, that's what that semicolon is. It's telling us we're done with saying a phrase or a statement. Light.enabled is true, semicolon. Or else light.enabled is false, semicolon. End of thought, end of statement. Without it, Unity does not know when to end what we've talked about. So let's leave that as an error. Let's save, and we can see we've come back to Unity and there is an error. Click on it. It highlights the script that's giving us the problem and brings up the console. Console is split into two sections. Top part shows us the first two lines of any error. These are very short errors. They're only one line long. But you can get errors, especially when you get into a trace that shows you where the error is coming from. That can be much longer, and you need to expand this bottom section until you see the full error. This bottom section you can copy. Let's see, pick this one. You can copy and paste. So if you're dealing with someone on IRC or the forum, and they ask you what the error is, you can simply come to Unity and you can copy and paste that error, and they can see it exactly. The way that you read these is it tells us that in assets, which is our assets directory, there is a script called demoscript.cs. That's our script. 17 lines on line 17, 17 characters in, there is an error, and we can ignore the error number unless you really get desperate. And it tells us that there's been an unexpected symbol, end bracket. It was expecting a semicolon. So the way we solve this, double click on the error. It'll load your developer's environment. It'll load the script into it, and it will highlight the line that's the problem. Sorry, I just bumped that. So you can see that it's, well, I don't know if you can see that in your, this is highlighting here, this line 17. Now in C#, it's a little bit confusing. It's saying I'm finding this end bracket. The JavaScript one is error is a little bit better and says, where's my semicolon? But basically add the semicolon, hit save, come back, it'll recompile, the errors go away. Now we need to attach our script to our component. We need to attach our script as a component to our game object. And how do we do this? Well, we can select the light object, go to our component menu, and you see there's scripts down here, and there's demo script. That's one way to do it. I'm now going to undo. You can come here and add component. There's scripts. There's demo script. That's not bad. Undo as well. But there are easier ways. You can simply grab the script and drop it on. Now, if we don't have the light selected, or we have another game object selected, you can still drag and drop that script onto the light. When you come back, you'll see it was attached when we let go. And if you want to drop it onto a child object, you need to make sure that you've exposed the child object, or hover and wait, and it will open up the family, and then you can put it on the child object. If you put it on the parent, it'll go to the parent game object, not the child. So you need to drop it on the game object that you want. Now that it's attached, it's going to do its job. We don't have any parameters, but it's going to do this. At every update, every frame, it's going to look for our input, and if our space bar is being held down, it's going to turn on the light. If it's not being held down, it's going to turn off that light. So let's hit save, let's hit play. We can see the very first frame, the light is off. Hold down the space bar, the light goes on, lift it off, it goes off. On, off. So if input get key space, light.enabled is true, or else light.enabled is false. Now, let's take a look at this code though. Means that every frame we're setting this value. Every frame, light's true, light's false, light's true, light's true, light's true. When you're holding it down, you let go of the space bar, light's false, light's false, light's false. Let's look at another way of doing this. Let's just say if, oops, don't need 3, input get key down space. And this is a different function, a different command. If we're asking for the frame the key came down, as opposed to get key, which says every frame, is the space bar down, yes or no? Is the space bar down, yes or no? This is saying, is this the frame the key came down? So if this is the frame the key came down, let's set our light to be enabled, light's enabled state to be true. And if it's the frame the key comes up, let's set it to be false. Oops. So I've got 2 if statements here. Okay, well, I'm checking 2 things twice, but I'm only setting that value once when the key comes down and once when the key comes up. So it's 2 different ways to solve the same problem. Partly the way I want to show you this, though, is let's take a look at what happens when we come back to our game. We hit play, and we see that the light is on. I hold the space bar down, and I go from on to on. I lift up my key, and the on goes from on to off. And from then on, the behavior is the same, but that very first beginning of the behavior, my light is on. And then it gets funny because I hold down the key and apparently nothing happens until I let go. So the behavior is different from the first piece of code that we had, which is the very first frame the light was off because I wasn't holding down the key. 2 seconds. Are you saying there's no audio? Yes, there is currently audio. You okay? I'll help you out if it's not. Cool. So the reason why I'm showing you this is sometimes when you make a change to the code or you've written the code the way you want it to be in your scripting environment, you need to make a change in your editor. So now if we change the light's initial state in edit mode to off, we hit save, we hit play. Now the behavior is the same. The light is off that very first frame. Key comes down, the light goes on. Key comes up, light goes off. So we have the exact same behavior. Your player would never tell the difference between the 2 of these. And we made a small change to our code, and we made a change to the enabled state in our editor. Let's take a look at this with maximize on play off, just so you can see it. If with maximize on play off, you can see that every time I hold down the space bar, that enabled state goes on as well. So you can see this as feedback in the editor. Sometimes you can get faster than it can update, but you can see that as feedback in the editor. So I want to make one more change to my script, and it's going to make a slightly larger change to our behavior. If input get key down space, if this is the frame the key came down, my new lights enabled state is going to be equal to the exclamation point. Whiskey Tango Foxtrot. What's an exclamation point? Not. Oh, get rid of that, please. Not. There we go. So you can have true, and you can have not true. But that is the same as false. And then you can have not false, which is the same as true. Why do we care? Well, sometimes we are dealing with a Boolean value in a variable. And we don't actually know its current state, whether it's on or off. You'd have to ask it, because you just have this thing called Boolean variable, some name. An example of a Boolean variable is light.enabled. Is it true or is it false? So we can say, I want my new lights enabled state to be equal to the opposite of my current lights enabled state. And this makes a toggle, because every time the key comes down, if light.enable is false, it becomes true. If light.enable is true, it becomes false. So let's save this. Let's come back to Unity. We hit play. I hold down the space bar and it goes on. Hold down the space bar again, it goes off. So now every time I click it, it simply reverses the state. My new light.enabled state is equal to the opposite of my current state. How does the demo script know the lowercase light is a reference to the existing game object? Because it's built into Unity, and we'll see this in just one moment. So the API, or built-in functions, are very important. This is where we get to see this. This is how you drive the Unity game engine, is through the API. The easiest way to get to the API is through the scripting reference. And the easiest way to get to the scripting reference is help, scripting reference. And it opens in another page. There we go. Come over here. We can see that this is a scripting overview. This is the first page in the scripting reference, and this is a short overview of how scripting works in Unity. Scripting in Unity consists of attaching custom game objects called behaviors, or custom script objects called behaviors to our game objects. And then different functions inside these script objects are called on certain events. The two most common are update and fixed update. Update, this is the function that is called before rendering a frame and where most of our game code will go. Fixed update, this is the function that is called once every physics time step before calculating our physics-based interactions, and this is where our physics-based game behavior goes. And I'll talk about the differences between the two of these in just a minute. Now, what I want you to do, homework time. This is homework. Read these. Read these common subsections. There's about a dozen of them. And the reason why I say this is most people come to Unity and they just start playing. And they do watch some videos and they do come to this class and they don't read this. These, if everyone here in this class were to read these common subsections, they would get more information than most people coming to Unity. And many people only figure these out months and months later on as they need to see it. Common operations. Just this long, no scroll bar at all. Next one is time. Keeping track of time. It's a little bit larger. What's going to take a minute or two to read these? You could probably read these all in 20 minutes. Accessing components. And this is where you'd find out about accessing components. Components are attached to game objects. And the most common components are accessible through simple member variables. So you can get a hold of the transform component with a lowercase t transform. You can get a hold of the light component only if there's a light object with a lowercase light. So this explains how this works. And most of these, you can literally see it's a question of the capital letter, transform, capital lowercase t, rigid body, renderer, camera. And if you don't have a light, it will return null. Accessing objects, vectors, vector 3, x, y, and z. We'll come across this a bunch of times when we come up on this when we make our game. So take a look at vectors. Vectors are very important because this is how we describe both distances and directions in 3D space with an x, a y, and a z value. So read those. Help, scripting reference, read those 12 common subsections, and you'll know more than most people who first come to Unity. So when we're dealing with our scripts and our scripting, you first start out by laying out your tools at the top. You declare your necessary tools. The most common thing that you declare is a variable. And you could, in theory, create and declare these variables anywhere in your script. It won't break the compiler. It'll just break your friendships with anybody that's trying to help you. So declare your variables at the top. Declare them in a way that you can understand. Now, I mean, compilers are very strong. You could write your code like this, and It won't break, but boy, is it going to annoy somebody. No one will. I have had people hand me scripts that were so unreadable, um, that I've said, look, this is how you format a script. You have to go back and reformat your script, or I can't help you. Um, the subsections for C# are essentially the same. I will admit that that's one section that is still somewhat JavaScript centric, but as we go forward, I'll show you how the languages are so close that you should be able to interpret the difference. One of the main differences, let's show you how I'll declare this variable in C#. You first declare its access, whether it's public or private. Then you give it a type. I'm going to make a light variable, so there's a light type, and I'm going to give it a name, my light. If I was to do this in JavaScript, I'd need a public my light, the name is first, colon light. So the syntax is just another way around. Same with functions, is that I'd be calling this function start rather than void start. But ultimately, the meat of these two languages are the same, and often you can simply copy and paste the JavaScript into the C# and it will work. So I have this public variable, its type is light, and I'm calling it my light. And notice the what's called camel casing. The variable starts with a lowercase letter, and then to make it more readable for me, I make an uppercase L partway through. Oh, right. And if you're talking about the different languages, sorry. This does sort of assume that this page sort of assumes that you're dealing with JavaScript. But yes, the different snippets are on the side. We usually cover that in the next section. But yes, you can see the snippets are in JavaScript, C# and Boo. But if you read this particular page, you can see that it talks about writing C# and Boo as in a separate page because this document assumes you're using JavaScript. But it's pretty much just this page at one point. When we're cleaning this up, trying to get more language agnosticism in all of our documentation. Now, what is a type? Int for whole numbers, 1, 2, 3. Float for a floating point decimal, 1.12.23.3. We have a string that's in quotes like string space. Anything that you want to say, which is text. The quick brown fox jumped over the lazy dog, as long as it's in quotes. Boolean are true, false, but in C# it's just bool. In JavaScript it's Boolean. And then our component types. Well, they're types. So light, camera, color, transform, rigid body. These are all types. Why do we care? Why do we need to know what types are? Well, there are a couple of reasons. The first one is Unity needs to know what type of field to put in the inspector. Am I going to put in a color field? Am I going to put in a float field that I've got a floating point decimal here? Is it a Boolean checkbox? So it needs to know these things. And then also, does it? Do I need a flare in this slot? Do I need a texture in this slot? Texture is one. Also, Unity is reading through our scripts and trying to make sure that we aren't making a mistake. Will it work? So if if we have A plus B, will this work? And Unity will look at that and go, well, A is an int and B is an int. 1 plus 1 equals 2. That works. A is an int and B is a float. 1 plus 2.2. That works. And in some cases, A is a string and B is a float. That works in some cases, but not all cases. But A is a light and B is a transform. These two things do not work well together. You will get an error. So Unity not only needs to know what type something is on how to deal with it in the inspector, it also needs to know how to deal with it in the script, and it needs to know whether our operations between these objects are working correctly. So now I've created a new variable, a public variable called light. Its name called my light. Its type is light. And if it wasn't public, I wouldn't be, if it was private, I wouldn't be able to see this in the inspector, and I wouldn't be able to access it from another script. So let's leave this as public. You can cast to it. Yeah, I mean, without going into the details, all of the normal scripting behavior is possible. And this is generally an overview of scripting. So you can have an object and you can cast to its type. Yeah. Or number. And then you can also do some things. You can force it to do things like my number dot to string, which is a built-in function that will then make that a string. But they have to be properly convertible. You can't try to make a camera into a color. So now I want to use my light and use it here in my light.enabled state to be not my light.enabled state. So this is my light now, rather than being the generic light that Unity gave us through that accessing component, accessing components where we were using that lowercase light or that lowercase transform. I've now created a variable of type light, and I've named it my light. I have control over this. This is my light. Come back to Unity and take a look at our demo script. We now have a slot. We now have a property. We're beginning to look like a real script now. So let's hit save. Let's hit play. The ball is going to roll down. I hit the space bar. And I have an error. Unassigned reference exception. Click on that and we get we highlight the object that's the offensive object and we see the error. Now note that this error is 3 lines long. So we don't see the third line here unless we lift up our movable section here in the bottom part of the console. If you read it, unassigned reference exception, the variable mylight of demo script has not been assigned. You probably need to assign the mylight variable in the inspector. Where does this happen? Well, you could also find out, double click on it, and it will show us the line where it says that's happening, where the error is. Just made a breakpoint. So we can see that, but it's nothing wrong with the script. That's just telling us where in our scripting things went wrong. What do we see down here? My light variable is not assigned. We see none. We want a light. There's our light type. We want a light type assigned, but there's none assigned. What we've done is essentially like moved tables in a bar and looked up at the waiter and said, "Hey, waiter, bring me my drink." He's going to look around the bar and see drinks everywhere and go, "Huh? I don't know which one's yours." Error. I don't know what. We've asked it to change the light enabled state. I want my light's enabled state to be equal to the opposite of my light's enabled state, but we don't know which light this is. So we need to assign this. We could drag the component in. That would work. Undo. We could drag the game object and we'll find the light component on it. But both of those we could get from that shorthand light. Look at the little target guy here. This shows us all of the possible objects when we have the scene. You can also look at assets. We just don't have any assets that will work. All of the scene objects that will work for this slot, and we can see the capsules show up. Not just the light game object, but all the capsules. And why is that? That's because all of these capsules have a light object on them, have a light component on them, excuse me. They have a light component. And so we can associate this slot with any light in the game. It doesn't have to be on the same game object as this script. So I can grab this capsule, drop it in, and now I have an association. You see a single click will highlight the thing I have an association with. I have an association with that capsule, and I'm looking at the light component on that capsule game object. Is that true for everyone? Or is that a downstream issue? Okay. Seems like it's downstream. Try DC and reconnect. Or make sure you're not muted. Which occasionally does happen, which is kind of embarrassing. So this is looking at the new architecture that you can see with, say, a game controller, where you've got a game object that doesn't have a renderer, doesn't have a mesh, doesn't have a rigid body, doesn't have a collider, sits in your game and has references to other game objects and other components on them, and starts to manipulate your game. A little bit like Cardinal Richelieu in France, working and associating and influencing the politics without ever actually having to go there. Can a game have multiple lights? No. In this example, can you tell which of the similarly named capsules are being referenced? Only by clicking on it, you can see that it'll show you which one. Multiple components, but many components you cannot duplicate. If you think about a rigid body, you don't want two rigid bodies on the same game object. You usually don't want two lights in the exact same position either. So if you really needed two lights that had different properties, you'd duplicate them and you'd say, big light. And you could make this one, I don't know, red and big. Something like that. Can you associate it with a prefab so it controls all of the instances of a light? Yes, except it gets slightly more complicated. I can show that in Q&A, but you'd want to make a list or an array and then load all of your lights into that list. And then you'd have to change your code so it looked at the list and you said, for every light in this list, please do this action. It will fail gracefully if you write the appropriate code. It will fail spectacularly badly if you don't. And so if you think that a game could be deleted at runtime, you do need to check to see whether that game object exists, because you can get things which are called a null reference, which is that it's referring to something that doesn't exist. And that's what we see down here. This was trying to refer to something that essentially in this case, didn't exist because we never associated it. But if you deleted that light at runtime, you'll get the same error. So we've now associated this new capsule light. So let's hit play, and we can see that I'm now manipulating not the overhead light, but the light on the capsule, even as it goes over the edge into the void. So functions. Functions do things to variables. There are a number of functions that run automatically in a script used by Unity. And I'm going to write out some of the usual suspects here. There is awake. And then there is start. And then there is on GUI. Oh, come back here. And then there is update. And there is fixed update. And there is late update. And there are many, many more of these that are all called by Unity that happen at different times. But these are some of the most common, sort of the usual suspects. I'll get to each one of these in a second. Awake and start only run once in the lifetime of the component. I mean, and as an example of some of the other ones that you can have, you can have on enable. So there's a lot of points of times where you're looking at different events. Awake happens first and then start, and Unity will run awake on all of the newly instantiated components for that frame. And the usual location for this is the very first frame of your game, in which case it'll look at all the components and all the game objects and run awake on them. Then, if the component is enabled, it will run start. But start only happens once in the lifetime. So if you disable and re-enable the game object, you won't get start running twice. But you can delay certain connections until start by waiting it. But you can delay certain things until it's enabled by putting it into start. On enable, on the other hand, will happen every single time you re-enable that component. Awake and start are good places to initialize local information. I like to initialize, say, values to variables in awake. The way I like to think of it is that you wake up and you get dressed and you take a shower and you get dressed and you comb your hair, brush your teeth. And then when you are ready to start your day is when you make connections to other game objects and other components. And you can do that in start. On GUI happens arguably once a frame. In reality, it happens many times a frame, and this is where your UI code goes. Currently, Unity's UI system is code-driven. It's an immediate mode UI, and so Unity reads through all of your UI code many times a frame, builds the buttons, looks for input on those buttons, and then shows your UI, updates the numbers, looks for touches, looks for clicks. Update, as we've seen, runs once per frame before rendering that frame. Fixed update, we talked about that when we looked at the script reference page. Excuse me, script reference page, and this is where all of our physics code goes. Now let me talk about the difference between update and fixed update. Why would we want to have two separate loops for physics and non-physics? Well, let's think about this. Let's think about a space game. And if we're just getting started with a space game and all we have is a spaceship and we've got a star sphere around us and maybe one particle system or two for our engines, we're going to have a very high frame rate because our frame rate is based on how much it takes to render and how much logic takes to be done. So we're moving our game object a little bit every frame and we're rendering the star sphere, we're rendering the skin, we're rendering the engines, very high frame rate. Then we get into a space battle in the asteroid field where we've got, hundreds of spaceships and we've got thousands of asteroids and millions of missiles and billions of particles that all need to be rendered on top of each other. Our frame rate is going to drop. So in both cases, we don't want to have our physics hooked up into the same loop because in that very high frame rate situation, we don't want to be calculating physics every single time, which is relatively cost effective for very little return. Yet at the same time, when you get to the space battle, where we've got a very low frame rate, we don't want to have our physics interactions not behaving properly, objects passing through each other, generally having bad physics behavior. So there is a separate time step, a fixed and regular time step that is where the physics code goes. And you calculate the physics regularly every time step. And in the high frame rate situation, you may render 2 or 3 frames before rendering your physics, before calculating your physics. In the low frame rate, you may have 2 or 3 physics time steps calculated before you render a frame. So that's why you want to separate physics from your rendering update loop. And last is late update. It's a little bit like the relationship between awake and start. Unity will run awake, will run update on all of the active game objects and all of the enabled components. But then before rendering the frame, just before rendering the frame, it'll look to see if any of those components have a late update, and it will run the late update. And it's good because occasionally you want to get last known states, and you want those states to be finished, so you could take them in late update. Also a good place for procedural animation or follow cameras. Because let's say we had a camera that was to follow around our player, but since we have no control over when that the camera is moving, it might move before the player and look at the player and move to that position. I'm now behind my player, and then the player moves, and then the player is hit by a giant moving ball, and then next frame it has to catch up. It wouldn't be very smooth. It could be jittery. Whereas if we move that same camera in late update, we know the character has moved, we know the character has interacted with everybody, and then we know that our camera will always be able to smoothly look at our player. So I'm going to get rid of these known suspects, and we're going to start writing our own functions. Let me quickly look at the questions. Does Unity have some exceptionally handling like in C#? Well, you have normal .NET behavior, but you also need to write some of your own code, like, if this is null, don't use it. Can we set default values? Yes, you can. Exactly that. Public int num equals 1. You can set that at that point, and then also becomes, when you do that, public int my int equals 1 equals 55. What this can also do is not only does it give you a starting value, but if you change it and then you want to reset that component, it'll reset not back. You can see this, my light went to none, my int went back to the value that we set. But you can also set this in awake or start as well. And this will override any value you put in the inspector, because this happens after the game has started. So you could put 100, you could make my int equal to be, 555. Save that. And then when you hit play, it's going to revert to that lower number because, let's make this something pretty more obvious, 88. Because that happens after the game has started. Shorthand references like light are available as part of Unity scripting, so you can use it on any script. If I understand what you're saying. So when we write our own functions, we start off with a return type, which in this case is going to be void. And then we have a function name, which starts with a capital first letter, like my function. And then there are parentheses and then curly brackets. And then when we call this function, everything that is inside the curly brackets gets executed. So let's grab this code up here from update, and then we can call it now using the function. So my function will call, when if input get key down space, we call my function, and then my function calls the mylight.enabled. We'll see that the behavior here is exactly the same, where we're manipulating that light. It's just now been slightly disassociated into its own function. Yeah, Conrad, that's basically the idea, is that that light component, when it's attached to the game object, and if you want to access it, you can with light, or else it will return null if there's no light attached. So you then would have to trap that null. So if you attach a light to it, some cases that null reference won't be a problem. In some cases it will, depending upon how your code is working. If I want to control the light component from capsule 1, from the script of capsule 2, do I first? You can't do that. That light component is only the light object on the same game. That light component, the light component on the same game object as the script. So if you've got a script on this capsule and you want to control this capsule's light, you still need a script that has its own variable. Light always is the light component on the same game object as my script. So what are these things for? Obviously, they're not being used because, they're just empty. And, coders, they're not like writers, actually, if you think about it. I think coders hate coding, and script writers and programmers hate programming. Because if they were like Herman Melville, who wrote Moby Dick, they would write tons and tons and tons and tons and tons of stuff just for the fun of putting characters on the page. And I don't see that from coders. So why do they keep these empty parentheses when clearly they do nothing? Well, they actually do something. I'm watching Zuriel as he's writing. he is typing. I hate to steal his thunder. Most of us love making lots of words, but it's still bad. Exactly. But if you think about what these are actually for passing parameters or arguments. Is that sometimes that's okay. But sometimes when you need to give a function a value so that it can process that value and either do something internally based on the value you give it or process that value and send you back a new value, you need to send it inside these parentheses. And if you see in the input class, there is a function called getKeyDown, and we send inside the parentheses the string value of space, and it returns true or false. So let's say in start, we want to add 9 and 2. But I want to do this with a reusable function. Now this is wrong. Let's start off with our key with our return type. So we're going to have void, and this is going to be wrong, but I'll fix that in a second. And then let's create the name. Let's call it add2. And then we've got our parentheses and our curly brackets. So we want to send add2 the value of 9 and 2. And add2 has to accept these values by creating a variable for them. Let's just call this variable 1. And see, I'm typing them as ints because they're whole numbers, and variable 2. They have to have different names. So I've got int var1 and int var2, and then we can literally add var1, only if I can learn how to use a keyboard, var1 plus var2. But this isn't complete. We now need to do something with this new value. So let's put it into a new variable called my return value equals var1 plus var2. Now this is vaguely legal, doesn't really do anything. So what we want to do is return this return value. We don't need to know where this is specifically in our script. Essentially, whomever sent us this information gets that back. Except this is wrong. We have to type our return. So we get 2 ints in, we add them together, save them in an int, and then we return an int. And so when we return an int, we have to tell us what the value is. These are void because these functions do not return anything. They just simply execute code. And then lastly, let's grab a hold of these with another int variable. Let's just call it myvar equals add2 9 and 2. So essentially, we send add2 9 and 2. They come in, get added together, put into return value, get returned, come back up here and get saved in myvar, and then we can do something with it. What are we going to do? We're going to put it into the debug log, and we're going to debug.log myvar. So now, when we save, we can hit play, and we see 11 there in start. But this is reusable code, so we can grab this and put this down here in my function. Now, if we save this and we hit play, not only do we see 11, but every time we hit the spacebar, we see it again. I think so. I think it's in the console. I mean, of your application. So if I went into console, in other utilities, and then you looked it up. I believe all of those are saved under the Unity editor in the console. In general, they're not that. You usually don't, but I'm just quickly checking. I'm in another Unity editor log. Yeah, so they are. Sorry, this was in my other window. Zorch. So there's the logs in my console in library logs, Unity editor log. So they are. So classes. We're not really going to go into classes today. Just remember that classes are collections of variables and functions. And technically, you can see that this script defines a class. But let's ignore classes for now. Just remember, you can wrap collections of variables and functions. As we see, this class is wrapping collections of variables and functions together for use and reuse later. It's somewhat intermediate stuff, and we can talk more about that in Q&A if you want to, but not within the context of what we're doing today. So let's take a brief break. Let's come back at 10 minutes to, so a 9-minute break. So let's say break. And then back at 22:50 by my clock. Conrad, I don't know. Actually, I would assume it did, but I haven't tried. And it is a beta, so no guarantees. Anyway, I'm going to go off mic, and then I will be back in a few minutes. All right, welcome back. We do the webinars right now once a week. I do 101 and 102 once a week on average, unless I've got something pressing at Unity. But we don't have any plans of expanding that beyond 101 or 102 right now because we're concentrating on the persistent material on the Learn website. You should be able to set your time zone, but often it forgets to update for summertime. Exactly what Shadowed Ice has to say. Cool. All right. Let's get back to it. And let's make a simple little mini game. We're going to be making a very simple but playable game to use all of the concepts we've seen so far. We're going to show how to create game objects, add components, set their values, position these items in the scene to create a game and gameplay. We will not be working with imported assets today. We'll be doing that tomorrow. This means no models, no textures, no sounds or animation. They're all beyond the scope of today's simple introduction. We will be using the primitives, the simple primitive shapes that we get from the Create menu inside the hierarchy. We will be making a rollerball game where we will collect some special objects. I think it's important to note that we're not necessarily going to be creating a game in the best way possible. We will be bypassing some advanced solutions and some pre-made solutions and certain concepts we're going to overlook for the sake of simplicity today. But I will note these omissions whenever possible. So let's first start by cleaning up. Let's create a folder. And this creates a new directory on our hard drive. And let's call this demo. And then let's put in our capsule and our demo script. Let's hit save. Let's go ahead and get a new scene. And then we also want to save this new scene as well. Let's save this into our scenes file and let's call this one mini game. And we now have a mini game scene, and we can see that with mini game up here, Unity 101, PC, Mac, and Linux standalone as our build target. So let's start off by creating our play area. And let's do that by putting down a plane. And remember, this always appears where our game view camera, or sorry, our scene view camera happens to be looking. So let's reset this so we're now at the origin point, and then let's do a frame selected or focus so that we can see that game object. Now I want to scale it up, so we can go and pick the scale tool and scale it up that way. We could grab the title bar and scale it up that way, or we could simply type in the values we want directly. Now, remember, this is a plane, so planes have no volume. They're just simply flat. So Y scale does nothing unless you get into negative numbers, in which case it just simply faces the other direction. Remember that our planes are also single-sided, like so many things computer. So if you place a plane in your scene and you don't see it, check to make sure that you don't have a negative value in the Y, or make sure that your orientation to the plane is somewhere that you can actually see the surface. Now that we have this in its right location and its right size, let's name this. Let's name this our ground. Name that anything we want to, and then let's go ahead and create a sphere, and this is going to be our player. So that sphere is our player. We can see that we are focused on the origin, so our player came in at origin. If we're worried, we can reset it. And then we know when we hit frame selected or focus, we can see that it's buried in the plane. It's a 1 unit sphere. So if we bring it up by half a unit, we know it's resting on the surface. So when we look at our game view is too dark to see anything. Can't see it at all. So let's add a light. We can do this by creating a new directional light. Directional lights act like the sun, and they light every game object that we have in our scene, not based on the location of the position in the transform, but based on the rotation. So we can see as we change the rotation of this game object, you can see how we're changing the lighting. But if we change the position, makes no difference at all to that light. So I'm going to reset this. And let's go ahead and reset that light. And we can see that there's that directional light there at origin. And we can see the gizmo showing which direction that it is lighting. And we can see that as I move this around, and even behind it, I'm behind my game object. It's not making any difference to the lighting. It would only make a difference based on the rotation of the game object. Reset that back to 0 again. If I had a different type of light, like a spotlight, you can see it's no longer lighting the player because its position does make a difference. So I need to worry about the position and the rotation of my spotlight. Go into local view, let's push back out. And we can see that now I'm lighting almost like a spotlight in a theater. We can change the spot angle and then our range and our intensity. Note that you can see that intensity isn't changing, but it isn't changing the range. If we didn't change the range, it appears to get brighter at the ball, but that's just because we're spreading that same amount of light over a larger range. Let's go ahead and reset this. And if we had a point light, it's sort of the opposite of that that directional light. With a point light, its rotation does nothing. The opposite of that directional light. And that's because if you think about this as a bare light bulb, so as a bare light bulb, its rotation won't make a difference. But it's making the same amount of light everywhere, but its rotation, I mean not rotation, but its position does everything. Let's bring this back. There we go. And so its position in the scene makes a very big difference. Let me reset that again. Let's go back to our directional light because we want to light the whole scene. And let's tilt down on the game board by about 30 degrees. And then I think it's kind of boring to have the light in line with the camera. So also let's tilt over about 60 so it gives us some shape on the ball. Now, exactly that. We don't, it's hard to see where this ball seems to be hovering over this gray field, and that's because we don't have any shadows. So let's go ahead and add shadows. And this is currently a pro-only feature. And it's one of the only pro-only things that we do in this particular demonstration. And I'm going to make these soft shadows, and I'm going to make them of very high quality. We can talk more about shadows during Q&A, but right now we're just going to forge ahead. And this is just so that I can show you that we've got some shadows, and now that sort of grounds that onto the game board. What I'm finding is a difficult problem, however, is I can't see where the ball ends and the shadow begins in some cases because they're both dark. So what I can do, a little trick from theater and television lighting, let's call this our main light, and then let's duplicate this light and call this our fill light. And then I'm going to reverse these two values to -30 and -60. And you can see now it's coming up from below. It's still from the front, but up from below. I'm going to reduce the value down to 20% and then give it a hint of blue. Now you can see I've got filled in that little backside of the ball, and I can start to see the separation from the shadows. What I don't like is that my hierarchy is getting confusing and it's very disorganized. I only have 5 game objects. It's already hard to see what's going on. So let's go ahead and create a new empty game object. And we want to use this not as a game object to hold components, but to hold other game objects for organizational purposes, like a folder or directory. So let's go ahead and reset this value and call it lighting. And then let's put in our fill light and our main light. And we can start to see now we have some shape to our hierarchy. Also, what this will allow me to do is that since these lights, these directional lights, light the whole scene based on its rotation, not its direction, these gizmos that are all here where my player is, I can actually grab this lighting parent object and lift it up by 100 units and throw it up into the air. They're lighting the entire scene, and I don't have to worry about seeing that gizmo. And now we've got a very clear shot of that fill light that we've got going on here. Without the fill light, with the fill light, helps us a little bit. So we have our ball, we've got lights, we've got cameras, we've got actions. Let's see if we can get this ball moving under our control. There's two notes here. First one is we're going to be ignoring basic character controllers supplied by Unity. There are several available on from the standard assets in your downloads and also from the asset store. There's a very good third-person MMO style character and camera controller that you can go up. It's free from Unity, and you can download it, and it'll be very similar to Guild Wars 2 or Worlds of Warcraft. We also need to get input from the player, and we're going to be ignoring something called the Input Manager, which we'll look at tomorrow. The Input Manager provides a toolbox that assigns external input from sources like keyboards and mice and joystick into game code. But we'll see that tomorrow. Today, we're going to simply grab those keys the way we've done before with the input get key. So how do we move this player object? With a script. Now we could create a new C# script here in the project, but we can also create them here with the new script button. So we can say new script. We can call this our player controller, and you can see that it's automatically attached. And I actually went so fast I didn't show you that you can also pick the language, and we're going to pick C#, which is what it always defaults to the last used language. So we've got our player controller, and we can see that it's automatically attached here. So we can go ahead and edit that script, and it comes into MonoDevelop. What do we want to do? Well, we want to get our player's input. But what do we do with it? I mean, great, I've got input. Now what? Well, if we want to find out more, we can highlight any item that we have in our script that we want to research, and then we can put down behind command plus single quote on the Mac and control, oops, look at a C please, control plus single quote on Windows. So that's a little cheat sheet. So let's go ahead and grab this so we can see it, put it up here. And then I can select my input and hold down the command or control key, single quote key, and there is the page on input. We can see that this is the interface into the input system, and we use this to read the axes set up in the input manager, which we are ignoring today, and to access multi-touch and accelerometer data on mobile devices. We can use this to read the input get axis or the input get button from the input manager. We can also on mobile devices. So if you want to know how to use this class, you read the text at the top. So that's how to use the standard input manager. Here's how we use it for mobile devices. It touches, the input acceleration, device orientation. So you can follow any one of those as links. And then in the body of the page, we see class variables and class functions. Variables, remember, do things. Or sorry, variables hold things. Crackers. The variables hold things. So there's a reference to the default gyroscope. And then we can get the number of touches as a value, a reference to the compass. And so these are all things that we need to get a hold of. There's our current acceleration. You know, so I can say my input acceleration, how much X, Y, and Z value has been, what's the way you can use that to find out how the device is moving and changing. You can get device orientation. And then, so this gives us things that we can get a hold of, and then functions do things. We can get our axis, we can get our button, or in our case, we can get our key. And you read down the description until you find the thing that you want. Returns true while the user holds down a key identified by name, think auto fire. Then you click on the link to find out more. In our case, get key. So input get key, you can see that that's the title, and then you see a signature. Currently, this is in JavaScript, and this is going to become, in our new scripting reference, agnostic, so that as you change this to C#, this will also change to C#. This is currently in JavaScript syntax. So you can see that it's a static function called getKey, and then you give it a name as a string, and it returns a Boolean. So if input get key space, and then it returns true or false. We've seen that earlier today. And for a list of key identifiers, you can see the input manager. We're not going to be using most of the input manager today, but if you come down, we can see a list of the button names, A, B, and C, and D, 1, 2, 3, up, down, left, and right for the arrows, inside brackets for the keypad keys, mouse buttons, joystick buttons, special function buttons. So you can reuse this list to get an idea of what your keys are going to be called. And then we've got snippets, JavaScript, C#, Boo. If we look at this, note that from update all the way down to the end, it's the same in JavaScript and in C#. So the meat of these codes are the same. The only difference is that in C# you have to explicitly type your return. You need to explicitly wrap your code in a class, and then you need to declare your namespaces. And all of this is done for you under the hood with JavaScript. You simply just need to see that keyword function. So we could just grab this code from JavaScript. We could also grab it from C#. If input get key up, excuse me. So we could copy this and then simply paste this into our code. I'm going to correct our indents because we may have picked up some extra spaces. If input get key up, well, let's not use the up arrow. Let's use the W key of the ASDW or WASD keys. And then, oops, curly brackets, please. So if input get key W, then what? Well, let's think about what it is that we want to do. We want our ball to roll around on the play area. We want it to not fly off into space. We want it to stick to the ground. We also want to collide with collectible objects and have our collisions help pick them up. All of this sounds like we need physics, we need gravity. Sounds like we also need, got something in there, a rigid body. Physics, rigid body. Now, if I want to rearrange the order here on the of my components, I can do that with the context-sensitive gear menu. You can see I can move that up. I can move this up and move this one up again. And now I have them. So I've got my mesh filter, my mesh renderer, my rigid body, my sphere collider. This makes no difference to the performance of this game object, but it can help me organize my my environment, because if I have all of my game objects with the same order of the same components, then I can quickly find and reference things and see if anything is missing or know where to go when I'm looking for something. So we now have a rigid body. We now have used gravity. We have mass, and we can also interface with the physics engine. So that means I can now address this rigid body in my code. Rigid body. And remember, the lowercase r means I am accessing the rigid body component on the same game object as this script, which is what that is. So that lowercase r means I can get a hold of this rigid body. Find out more, select it, and remember the little cheat sheet, Command or Control, single quote, and there's the rigid body page. Controls an object's position through physics simulation, and it takes the rigid body component and takes control over the object's position, makes it fall down under gravity, and can calculate how the object will respond to collisions. One of the things I want to show you is I have sort of done a little bit of a shortcut here in Unity and not told you about something. We've talked about the component with its header, and it's got its icon, enabled button if possible, its type, and a little blue book. That's the component reference. And that's different from the scripting reference. The component reference and the scripting reference. The component reference talks about how we use this component in the context of the editor. We can see that there's a picture, and we can see the component from the editor. And then here under properties, it describes all of the properties that we see here, including the turn down. So if we see interpolate, We've got none, none, and there's interpolate and extrapolate, and it talks about how to use them. And we can come down to see the details, parenting, scripting, and animation colliders. When we talk about colliders, there are links to all of the colliders in the game. Compound colliders. Remember, we were talking about making around the player. We had put a simple capsule collider because it made a very simple collision mesh. We didn't use the blue lines of the mesh of the creature. And so the same thing we have here is we don't want to use the mesh of the gun, but one collider isn't going to be good enough for this particularly complex shape. If you just made it a box or you just made it a capsule, it wouldn't work. So we're using multiple child colliders, and still having 5 primitive colliders is much more efficient than trying to use a mesh collider for that same object. Then it talks about continuous collision detection, using the right size, and then some hints. So if we want to find out how to use this component in the context of the editor, we look at the component reference. If we want to know how to script to the class, we looked at the scripting reference. But also, notice that I'm sitting here in the scripting reference. They have a switch to component button, so you can switch back and forth if you're curious. Did I miss a way to immediately locate a type with a menu item or keyboard shortcut? Does such thing exist? Yeah, I mean, that's what we're doing here. The type rigid body, click on that. And this is the component reference. For scripting, we either need to switch to scripting or you need to search the scripting reference. But notice this works for all of these. There's the mesh filter, and there's the mesh renderer. Talks about how to render our mesh. And then we've seen the rigid body, sphere collider. And so this is the sphere collider. And then if we look at the script, unfortunately, it's not prescient enough to tell us what our script is about, but it talks about the mono behavior that we derive all of our attachable scripts from. And does this start to look familiar? We're looking at variables, we're looking at functions, and then we're looking at overridable functions like update, late update, fixed update, awake, start, reset. And we talked about on enable, which is in here somewhere. So these are all of the functions that you can grab a hold of, on enable, on disable, on destroy. Inherited members, rigid body, camera, light. Again, that's that list that we saw where the lowercase allows us to get a reference to the component attached to the game object. So you can look at, you can get the component reference here, and then you can use command single quote or control single quote to get the scripting reference. So, rigid body. In one sense, it's the same thing. You read the top part to figure out how to use the class, and then in the bottom part, we see our variables. What's our velocity? What's our drag? What's our current? Are we currently using gravity? And functions that do things like set density, add force. But if we look at add force, we can see that the code snippet is in fixed update. And it doesn't make a difference whether you're in JavaScript, C# or Boo. It's fixed update. So before we look at this specific detail here, let's go back to rigid body and finish reading the top part. When manipulating rigid body parameters, you should work inside the fixed update function. The physics simulation is carried out in discrete time steps, and the fixed update function is called immediately before each step. If we follow through one of these links, we get to the fixed update function, and we see that when adding force to a rigid body, you must apply that force every fixed frame inside fixed update. And we can see, looking at C#, void fixed update, rigid body add force vector 3 up. So let's copy this and come back in, but I don't want to paste this directly in my code. I want to paste this as a palette because the first thing I want to do is fix my function. I want to move from update to fixed update. I'm also going to get rid of all of that extra garbage at the top. And then we can see there's a rigid body add force. We can copy in there too. So if in fixed update my input is get key W, I want to take a rigid body add force, and it's suggesting vector 3 up. Well, remember we were looking briefly about vector 3's, x, y, and z. There are positions in 3D space. We don't want to go up with the ball. We want to go on the z and the x. We want to go forward and right. So what do we have with vector 3 up? Well, let's look at the vector 3 class, and we can see it's made up of x, y, and z. And this structure is used to pass 3D positions and directions around and for doing common vector operations. And that there are class variables for forward, up, and right. And remember x, y, and z, so right is x, 1, then 0, 0 on the up and forward, or the y and z. Forward is the other way around, 0x, 0y, and 1 on the z. So forward is 1 on the z. So what we can do is use vector 3 dot forward. Let's copy that and paste that in. So not vector 3 up, but vector 3 forward. So if input get key W, if we're holding down the W key, rigid body add force, vector 3 dot forward. Let's save this. Let's come back to Unity. Let's hit save and play. Hold down the W key, and the ball starts moving. Fantastic. Let's look at that without maximize on play on. Let's save and play. Hold down the W key. Come to local mode so we can see it. And the ball starts rolling. Wait. No, don't. We can't come back, though. But that's easy enough to do if that vector 3 forward on the W key. So let's copy this and paste that in. And we want to go the other direction, which is the S key. And let's just, let's multiply this by -1. So that's just the other direction. So if we save this, come back to Unity and hit play, and hold down the W key, go forward, okay. Hold down the S key, and we slow down and come back. Okay, that's working. You can see how this is working. So why don't we copy both of these, paste those in, and add in our A and D keys. And what did we know from here? Vector 3 forward and vector 3 right. 1, 0, 0 instead of 0, 0, 1. So we can say vector 3 dot right. Save this, come back to Unity, and hit play. W is forward, S is back, A, well, that's not left, and D is definitely not right. So there's something wrong here. Well, if you think about it, A is on the left and D is on the right, so these are backwards. But also, I don't like this. I don't like times -1 seems pretty darn ugly. So let's think about this. If we can have 12, we can have -12. It's on the other side of 0, which means if we have a value, we can have a negative value. And vector 3 is a value. So you can have a negative vector 3. Yes, but we'll get to that in just a second. So what we can simply do here is we want negative vector 3 right and negative vector 3 forward. Save this, because this is happening every frame. We're checking for all 4 inputs. You can hold down all 4 keys, but then these two are going to conflict. Minus forward and minus right and right would just stay in place. But if you hold down the W and the A keys, you're going to get forward and minus right. So it's going to go forward and left. So you can come back here, you can hit play, and now we can roll around on the game board by holding down the various keys. The problem I have again, very, very slow. So we need some way to speed this up. Vector 3 dot right and vector 3 dot forward are interesting, but they're only giving us a value of 1. And we're adding 1 every fixed frame. What if we want to go faster than 1? We can't really change this number. Well, you can make a new tool. We can make a public float called speed. And we could multiply this by, say, 10, and it would go faster. But if we didn't like that, we'd have to come back into Unity, or back from Unity into MonoDevelop, change this number to something else, and then save, recompile, come back. Takes time. But if we multiply by speed, that speed is going to be accessible inside the inspector, and we can simply change it in edit time. We also need to change by multiply by one other thing, which is the time it took to render the last frame. And this makes our game frame rate independent. Time.delta time is the time in seconds it took to complete the last frame. You use this function to make your game frame rate independent, and when you multiply by time.delta time, you express, I want to move this object 10 meters per second instead of 10 meters per frame. And when called inside MonoBehavior's fixed update, it will return the fixed frame rate delta time. So we want to multiply each of them by speed and time.delta time. So we have, we have control over our speed and we're frame rate independent. So let's hit play, and we have the speed of 0, so we're not going to go anywhere. Let's change this to something meaningful. It's going to be about 500. So let's save, let's hit play. And now we can move around with a certain amount of speed. There we go. Woof. You could with different code, because right now we're manipulating this using forces, and so we're giving it momentum. And you'd need a more arcade-style way of doing things, you can do that by immediately changing the rigid body velocity. We can talk about it in Q&A, but there's other ways that you can attach the rigid bodies to immediately change. But currently, since we're simply adding force, you add force in that direction of forward. And then you have to add force in the other direction to get it to slow down, because it's simply by you're adding force to it. So these are physics forces. But if you wanted to change the way that you did things, you could do that. It's a different script. Yes, if you end up, all of the similar classes all contain similar content. So if you needed to pick this up on another day, you'll get a very similar class, yes. So we're moving, but our camera down here doesn't see very much at all. The force is coming from our script and the physics engine. We are essentially telling the rigid body, which is our access point into the physics engine, to add force to itself based on these values. So the force comes from this line. We're saying, rigid body, add some force in this direction. And since the rigid body is attached to our game object, the rigid body is basically asking the physics engine to touch that game object, but basically like blowing really hard, adding a force. Because it's not particularly set in the way that we have this set up on a point on this object, it is very much like putting a very strong wind behind it and blowing it, and the ball just naturally begins to roll. The same way we get the roll comes from force from behind and then friction with the surface. So it's actually rolling. And you could find a point, more complicated code, like you're doing very complicated physics-based billiards. You could actually hit at an angle on the surface from a point. Look at friction. But it's beyond what we're doing today. So let's take our camera. It doesn't see very much. So let's come up on the game board. So let's take our main camera and come up 10 units. And then let's tilt down 45 degrees. So we're now looking down on our game board. And we apply the force the same way. And you'll see this right now as I move the camera. But I want it now so that when the player moves around, the camera moves with it. So I'm just wanting to just be static on this game board. I want to actually have it so the camera moves with it. And let's make a very typical third-person camera setup. We'll just make the main camera a child of the player. And when the main camera is a child of the player, remember you move the player game object around, and the camera moves with it. And then you rotate that player game object, and you can see the camera rotates with it. So it'll always be behind that player game object. So let's hit save. Let's hit play. Hold down the W key and realize that we've made a terrible error. Well, our main camera isn't rotating, but it's directly relative to the immediate parent, which is the player, and the player is rotating, so the camera's point of view is going to rotate like crazy. So this isn't going to work. But we want that same basic relationship, which is that when the main camera is a child of the player, at any one point, the main camera's position is, let's make these just even numbers, 10 units up and 10 units back from whatever the player's position happens to be. Now, the reason that this works in a third-person setup is that the player slides along the bottom of his capsule and never actually rotates. It rotates on the Y when it turns to look around left and right, but it does not rotate. It doesn't rotate on the X and the Z, which is what our player is going to do as a ball. So we need to come up with a script that does essentially the same thing. We want to come up with a script that takes the player's position and calculates our offset. So on the main camera, let's add a new script called camera controller. And that camera controller script is going to need two references. It's going to need, or two tools, two variables. It's going to need a public game object reference to our player, and it's going to need a private vector3 value for our offset, which is the distance from the player. Now we can set the offset value in start, because essentially the offset value we want is our current position, 10 and minus 10, and that is our transform position. So we can say in start, our offset is equal to our transform with its lowercase t position. So it's going to find the transform component on the same game object. And then every frame, we want to say our transform position is equal to the player's transform position plus our offset. Now we can use this lowercase t here because we know what the player is. This one is finding the transform component on the same game object as this object because there's nothing before it. And this is finding the transform component on the player. So now every frame, our position is equal to the transform's position plus our offset up and back. Come back to Unity. Let's save. Let's play. Oh, and we forgot to assign the reference. Sorry, jumping ahead. We've created this player reference. Let's put somebody in it. Yay! So now we have a reference to the player. And then every frame, let's hit play. Every frame, as we move the player along, our camera will move with it, even as we go over the edge. So let's put down some spinning collectibles. Let's build some walls. Let's pick them up and count points. So let's start off with some walls. I'm going to create a new holder game object, and I'm going to simply call this one walls. And remember, when we're using game objects for holders or containers, and we're using them as a directory, we want to make sure they're at origin. So we want to make sure that unless we've discretely and intentionally moved one, that we create them at origin. That means the things we put in them will always maintain their appropriate transform. You can see how those numbers make sense. Whereas if these had a wonky number to them, and then we tried to drop in a game object, we can see we're 10 units up, 10 units back, and 45 degrees down. Drop it into walls, and we get just rubbish. And that's because, and we got some floating point error here. Let's reset my scale. It's always reference to the value of the parent. So let's make sure that these are at origin. So now we're going to create our walls. We're going to create our walls out of a cube. And let's call this one west wall. I'm going to reset this one to origin as well, and then drop it into my walls container. If I zoom in, we can see there's my wall. So let's scale it up. We can make it thin and tall and long. Or we can do that here by grabbing the title, thin and tall, and then long. Or we can type in some numbers like 0.2 for thin, or 0.5, say 0.5 for thin, and 2 for tall, and 20.5 for length. So let's hit save, and let's hit and position that. We can just push that out until it looks good, or we could simply type in that number, which is 10 units, because our ground plane is 2 by 2, but it's made up of 10 unit squares, so 2 by 2 is 20. So it's minus 10 to 10 in both directions. Yeah, sorry, Zapper, but GMT, a lot of people get messed up a couple of times. And GMT doesn't keep track of daylight savings time, and you have to calculate it for your local time zone. Now, I could create another cube and scale it up, but this is the right size. So I can also just simply duplicate this and move it into space, or type in the number. Let's call this one east wall. Now duplicate again, and we've got our, we've lost our focus. We've got our north wall. And our north wall, we want to reset back down to 0. And I've got two choices here. I can rotate till I get to 90 degrees, or as it's a cuboid, I can just simply rescale and then push it into place. Now, both of them are legitimate. Depends how you want to do it. You can rotate it and push it into place, or you can simply rescale it. Again, north wall becomes duplicated, and it's now our south wall. And then we save and make that minus 10. Sorry, minus 10, and then save. And there we're in place. So let's hit play, and let's test our walls. And we can see we're bouncing off them. Nice thing that we have that fill light as well. Take a look when we're looking here in the shadow. We can see that highlight. If we got rid of that fill light, boop, way dark, hard to see. Fill light in, start to see some detail. So let's make some collectibles. Create a new cube to be our pickup. So again, another empty game object. Let's put our pickups in it. Let's call this our pickups. I don't need capital R, U. Pickups. And then let's reset this. And so this is a game object, and we're going to stick into it a cube called pickup. So let's put our pickups. Let's put our pickup cube into our pickups, and then let's reset this just to make sure. So we have our pickup there, and I'm going to frame selected on the our focus on that cube. And my player is in the way. I could choose not to render him, turn off the renderer, but take a look at what happens when we look at the sphere collider. Still in the scene. He's in stealth mode. He's invisible, but we can still bump into him. So let's go ahead and leave the mesh renderer on and take the entire game object and make the game object inactive. That means all of the components are turned off. We lose the transform, the sphere mesh filter, the mesh renderer, the rigid body sphere collider, and the player controller script are all turned off because we've deactivated the game object. This allows us to play with our pickup. So let's lift it up by half a unit so it's resting on the ground. And then also let's make it a little bit smaller so it looks a little bit less like the walls, more like something we want to pick up, tilt over, maybe 45 degrees. But to be honest, that doesn't look like a complete pickup to me. One of the things I think about pickups is that they move. They move, they bounce, they change size, they change shape, they attract your attention and say, I'm not part of the static geometry. I'm not background geometry. I'm something you want to pay attention to. So let's create a new script. And let's call it rotator. And then let's open up our rotator script in MonoDevelop. Well, what do we want to do? Well, what I want to do is rotate the transform. I don't want to affect the transform rotation. I've already done that. I want to rotate this transform every frame. So what do I search for? Remember my little cheat sheet? Command plus single quote or control plus single quote? Well, here I can look for rotate, and we can see it's building a list for us. Or I could look for transform. And both of these are perfectly legitimate. It's just like using Google, or what's the new one, DuckDuckGo. You can find out about the transform, and if we look down on functions, rotate is the second function down, transform, rotate. If we look at rotate, we see there's a list of everything with the word rotate in it, in the API, and transform rotate is also the second one down. So let's stay here, and we can see that we are given, we have to rotate in the Euler angles of X, Y, and Z, and we're given an option of relative to. We'll talk about this slightly more tomorrow. So let's just copy that transform rotate and paste that in. And we can see that this is already frame rate independent, except I want to do more than just rotate to vector 3 right. I want to make a new vector 3 that is 15, 30, and 45. And this is just so it's a little bit more sexy. And in C#, we need to make sure that we have our new keyword in there. So the very simple transform in a rotator is an update does transform rotate new vector 3, 15, 30, 45. Save that. Hit play, and we can see it rotates around. I don't want to go into the total details of scripting in this case, but essentially you're telling us, we're telling Unity that we're making a new value, and we want to assign this vector 3 variable to a new value, and that new value is 15, 30, and 45. It's a bit of scripting that you don't require. It's done under the hood in JavaScript, but it's just required in C#. So let's spread these out. In 2 seconds, I'll do that, Ms. M. Knight. So let's spread these out on the game board. Also, don't forget, I'm going to give you this project when we're done. I will put it in Dropbox so you can all have access to this when you're done. So if I go into top-down, back out a little bit, I want to distribute a bunch of these around my game board. Sorry if I didn't mention that. I may have forgotten. Sometimes I do. because this class really is kind of lecture style, and I'll end up letting you have everything at the end. So if I spread these around, remember what we had with our concept of our theoretical treasure chest? I want to be able to make changes to my pickup. And if I just make duplicates of this, then I'd have to change every single one of them by hand. So what I can do is make a prefab. Remember the whole prefab thing? And then we grab our asset or our instance and we put it into the prefab. But what happens if we miss? Oops. It makes a prefab anyway. You don't actually need to populate a new prefab. You don't need to create that prefab and make an asset and then populate it. In recent versions, you can now simply drag anything you want to from your hierarchy into your project, and it will become a prefab. The only thing is, don't do it for silly reasons, because as we've discussed, once you make this prefab a prefab, you cannot unprefab it. Now you can rehook it up by creating a new prefab, but let's say we had that treasure chest with 1,000 of them and we blow away our master treasure chest asset, we would have to reconnect 1,000 of them by hand or write an editor script to be able to do it for us. So let's now duplicate a bunch of these. So first let's move it into position. I don't want it to be up in the air, I want it to be on the game board. Well, that's because we're in local mode. If I get rid of that and come back and put this in global mode, then I can move this around and I can stay on my XZ plane. So let's duplicate this and have two. Uh-oh, I have moved that in the wrong direction. Let's duplicate that and move that in two. There we go. Because I accidentally hit the Y arrow. So let's go back to looking top down. There we go. Duplicate, there's 3, duplicate 4, duplicate 5, 6, 7, 8, 8, 9, 10, 11, and 12. About 12 of them. That sounds good. Save and play. And now we've got a bunch of these guys going and rotating. Perfect. So they say, pick me up. So stopping that, let's bring back our player. And now we have to find a way to have our player bump into these and pick these up. Duplicate is just duplicate, Command D. You could copy and paste, but you can just duplicate directly. Sorry, we showed that earlier, and I've now skipped over that step. Yeah, there is ways that you can do this procedurally within the editor as well. You could create a single prefab and then have a script distribute them. You could even create the prefab in scripting as well. The most common way would be to create the prefab and then have a script instantiate all of your pickups if you're doing it procedurally. And we'll see instantiate tomorrow, definitely. So let's take our player. Let's edit the player script. And what do we want to do? We need to look something up. We need to look up some value. And it's going to be our collider is going to be what controls our collision. So we can actually look it up here with a little book. So there's our collider. But I don't care right now about how to use the collider in the editor. What I want is to look at the collider in scripting. So remember, I can look at this in by going to the book and then swap over. And then looking at the collider, I'm looking for something, some function that will help me deal with a collision. Now, look at the inherited functions. I mean, what do we got? Variables, they hold values. Is it enabled? Do we have a light? Do we have a camera? Okay. Inherited functions. Nothing here is really helpful. Neither is inherited class functions. But there are these messages sent. What are messages sent? Well, Unity has this system where there are events, and events send messages. And if there is a function on a script attached to a game object that is participating in this event, and the message is the same as the function, then all the code inside the function is called. So if we look at onTrigger is called when the collider other enters the trigger. So that makes sense. So if our collider enters a trigger, then we get onTrigger enter. OnTrigger enter is called when the collider other enters the trigger, and this message is sent to the trigger collider and rigid body that the trigger collider belongs to, and to the rigid body or collider if there's no rigid body that touches the trigger. And you need to have at least one rigid body involved in this collision. Okay, so let's copy this. We'll copy the C#. You can actually copy the JavaScript pretty much as well, but we'll copy the C#. Now, I don't want to destroy the other game object, but what I'm fascinated by is if in void onTrigger enter, we're given the collider whose name is other that we bump into, and we can get a hold of the other's game object. This gives me the hook that I want for my final code. So let's just drop this in as a palette. No, we're going to paste that all the way in. We want the onTrigger enter, excuse me. Let's paste that in and cut this out as our palette. We don't want to destroy the other game object, but I can find out more about the game object with command single quote. So there's our game object, and again with our shorthands, our list of shorthands. Tag. Oops, didn't mean to click it. The tag of this game object. So we can use that to identify objects by looking at their tag. And setActive activates and deactivates the game object. So as opposed to destroying the game object, I can deactivate it, just like I did with my player when he was there in the middle of my game board. So tag, gameObject.tag equals player. Okay, let's paste that in. There's part of my palette. And gameObject setActive deactivates the game object if you say gameObject setActive false. All right. So now I think I have all of my logic to be able to write my code. I want to say if the other game object tag is the same as, and notice this is a double equal. Single equal assigns a value, double equal compares a value, is the same as pickup. And we'll have to set this in the tag manager. If you look at tags, sorry, I jumped past that. Tag can be used to identify a game object. Tags must be declared in the tag manager before using them. So we need to do this before this will work. So if the other game object tag is the same as pickup, then what do I want to do? I want to take the other game object, and I want to do a setActive false. So let's get rid of all my stuff in the palette. So onTrigger enter, when the collider enters the trigger, we're given the name of the other collider. So if the other.gameObject.tag is the same as pickup, other.gameObject.setActive false. Now, when we come back to Unity, if I was to try this now, oops, what do I have to compare? Oh, whoops, didn't delete everything. So if I was to do this now, this makes sense. I'm going to bounce off because I haven't set up my tag. These are not tagged. I'm looking at the asset here. They're untagged. There is no pickup here that says, there is no tag that says pickup. So let's add a tag. This is the tag manager. Let's declare it. I'm going to copy and paste this so I know that there's no typographical errors. Boom, pickup. Come back. It's not tagged, but it's now in the list. Power of prefabs. We can see that these are all tagged pickup. But here, if I play, I still bounce off. And this needs a discussion about how physics and collisions work. Remember what we were saying about how the physics engine does not allow the penetration. Oops, come on, Mr. Sphere. Does not allow the penetration of two collision volumes, of two collider volumes. So I'm going to turn off their mesh renderers, because whenever you've got two objects selected, you can do multi selection editing. I can turn off both of their mesh renderers at the same time. So this leaves just our collider volumes left behind. Just move down. There we go. I can get a good view of these guys. And so when Unity sees the sphere trying to enter the cube, it performs a collision and it rejects these two objects because they cannot penetrate each other. And the first check, it says, hey, these two objects are trying to penetrate each other. Second check is which object is dynamic and which object is static. Dynamic are moving objects, static are part of your environment. The way Unity can tell this is which one has a rigid body. And so the sphere has a rigid body, the cube does not, so the cube doesn't move, it just stays there stuck, and the sphere bounces off. There is another way, however, that we can deal with collisions, and that's by setting on the box collider or whatever collider is trigger. And when you have is trigger set, let's find that invisible cube, Unity allows the penetration of the trigger collider. But it still keeps track of the fact that these volumes have intersected. And we use these to execute code. Imagine spreading out this cube so it fills the doorway of a room in our dungeon. We pass through it. We get an on-trigger enter. Well, the player doesn't notice it, but our map updates and says, you've discovered this new room. You put it on a bridge, and the player walks across. And when he walks into that trigger, the bridge starts to collapse. You come around that corner in the dungeon, and the spiders come out of the walls because the players walked through the trigger. So we use these to trigger events, and we can tell when something is into it. And the reason we want to use a trigger in this case is if we did a collision, and we can do a collision test as well, our player would in one frame bounce off these cubes while it was trying to collect them. Now imagine if Mario, jumping off of a platform through a nice arc of coins, bounces off the first coin. It does collect it, but actually strikes it, can't penetrate its volume, and falls down. You wouldn't want that. You want to be able to smoothly pick these objects up so that we want to make this a trigger. Yeah, you could set a trigger to, you'd probably set the trigger will always go off, and then your code says, when I go off, I have a 50% chance of actually doing anything. It's dangerous to go alone. Take this is You've Been Done Ludum Dare. That must be 3 years ago. 4? Oh, that's scary. 4 or 5 then. Anyway, it is dangerous to go alone. Take this. Oh dear. I actually participated in that one. Anyway, so moving on. There is a lull going on here. So we want to make these triggers. So let's put our mesh renderer back on. We've set these to be triggers. Now that these are triggers, we're going to get an on trigger message rather than an on collision message. We hit save, we hit play, and then we pick them up. Now quickly, in the last 5 minutes of this hair-raising adventure, we're going to do counting code and end the game. So counting code is very simple. We want a private, not a prop, we want a private int, because we're not going to have partial, 1.1 points for this. It would be whole points, called count. Just count them up. And then inside our onTrigger enter, if the other.gameObject.tag is the same as pickup, then we set it to be, it's set active to be false, and then our count, our new value of count, equals our old value of count plus 1. And there are other ways we can count up. There's plus equals, and there's plus plus. But we can talk about that later on or during Q&A. And then lastly, we need to show this. And to show this, we're going to do this in OnGUI. OnGUI is where our UI code goes, and we're not going to really go into what is the content of OnGUI today, but I'm just going to quickly use this. Otherwise, we won't get to see anything. And so I want to make a GUI label. And that GUI label is made up of a new rect. Again, note the keyword that we have inside Unity, a new rect. And that rect is going to be 10 pixels down, 10 pixels in, because it starts with a start X, a start Y, and a width and a height. And our width is going to be 100, and our height is going to be 20 pixels tall. And it's going to say, in quotes, our count, colon space, plus our count value. And you can do a thing called toString, which will format that number so we can add it to count. But Unity internally, if it sees a string and a number being added together, and the destination is a string field, it'll do toString for us automatically. And then lastly, if our count is greater than or equal to 12, then we want a new GUI label. Oops, not GUI text, please. GUI.label made up of a new rect. And that new rect is going to be in the middle of the screen. And we can actually ask the screen how big it is. The screen width divided by 2. And then we want it to be in the middle but up. Screen height divided by 3. And we want it to be 100 by 20 again. But since I don't want to start in the middle, I want this centered in the middle. I want to subtract half of that here. That's 50. And it's going to say, you win. So let's save that. Come back to Unity. Let's maximize on play. I don't have to worry because we'll always be centered whether I'm playing it windowed or maximize on play. Let's hit play. Let's, oh, make them, but you can't play them. Coming around. 7, 8, 9, 10, 11, 12. We win. Yay. Oh, and 2 minutes early. What can you say? So let me count this up. Let me clean this up, and then I'll distribute this, and then we'll go into Q&A. I'll stick around for, I don't know, upwards towards an hour. I'll also give you some resources of where to go next. So hold on to me. You guys can start putting your questions into the chat channel, and I'll get to them. So the two first things are, I'm going to make this for you, and then we'll give you some resources. So let me clean this up, create a new folder. The folder is going to be minigame. And then we're going to put in our camera controller and pickup and rotator. So we save this, and then assets, export package. No, because we have some stuff selected. Select nothing, please. Assets, export package, export to, and then 15. And then share link. So there is the package. Also, if you want to get a hold of me because you have been in this class, I offer a little thing, which is you can PM me any questions that you have in a particular way. If you write a forum post or an answers post, and then PM me the URL to that post, I will respond to it, or I'll find somebody who can. So anything that we can't answer today, come on, you can load. Go ahead and make a forum or answers post, and then PM me at this address, 1775, and I'll try to get somebody who can get you an answer for that. Now, when it comes to resources, I really think the main thing that we have is our Learn section. Come here to learn. If you want to show up to tomorrow's section and you haven't booked in, I will always free up some seats so you can come to the live training. And then tomorrow, you can see I freed up today's seats. I always allow people to register on the day if you want to come tomorrow. And then essentially, please be prompt or all your space will be given away. And that's what I do. I give away 10 minutes before class starts. Anyone who's not in their seat, I give away their space. Tomorrow's classes will be, we're going to cover importing assets like meshes, sounds, textures. We'll create materials using textures combined with shaders. We will talk about the input manager. We'll write more components. We'll be using the asset store as part of the pipeline, and we'll build and host a simple web player. And essentially, it's all done in the context of creating a very simple top-down shooter. Yeah, I mean, you can, if you're comfortable with what you're seeing, you can go ahead and move on directly, because today it was an introduction to the editor, an introduction to game objects and components, an introduction to scripting for people who've never had any scripting experience. So we talk about variables and functions and classes. Excuse me. And then we make the little mini game. So if you're comfortable with what you saw since you came in, you can go on to the next one. So other places to look is our tutorials. I mean, definitely in Learn, I've given you the overview, but our tutorial section is very good. And these include the Learn modules done by Will Goldstone and myself, and James Buckley, and then also David Llewellyn has done the art. So you can see here is our beginning. We can beginning editor, graphics, physics, audio. So they take some of the stuff that I've done here and they make them a little bit more granular. So when we talk about, you know, what is a texture, what is a mesh, what are cameras, and then assignments, which I'm working on right now, we'll show them in use, more like what we're doing here in our class today. There are projects to download. So you can download Stealth currently, and they can go through each one of these and learn about how they put together the Stealth project. You can download either the project itself. You can also download Robot Lab, which is where we do a lot of our teaching. And you can use, and anything that you download from us, you can use in your games. So you can use the characters, you can use the rigs, you can use the models, you can do anything you want to with them. Soon, I'm 96. We're still working on them. I mean, the drawback is I spend 2 days a week teaching classes, and then at least a day a week, if not more, doing doing Unity but non-teaching related stuff. So I only have a day or two a week right now that I can spend on creating new classes. So these are teaching. Community is important. Main thing here, forums and answers. And if you go to the forums, drop by teaching, because this includes free online training. Then we can talk about getting started with coding, Mechanim, a list of tutorials and resources, looking for answers, custom search engine. So if you have a question, then you can try it. Definitely try the search engine first, because you may find out that someone has already answered it. So if you have a question like water surface reflections was one I was dealing with before, or reflections. Yeah, and I like this one particularly because we discussed what it should look like and how involved they wanted it to be, and then they pretty much wanted something relatively simple. So I made a little video which includes what the water looks like, and we can see that it's flipped underneath and there's a reflection facing the other direction, and fog, and then I put in a little script as a way of starting people out in the right direction for making changes. So when this comes, so the fog level changes and that sort of thing, depending on whether you're above or below the level of the water. So those are some of our resources. Let me answer some questions. Oh, yes, and if you have any comments, criticisms, desires about this class, then it's here, that same crackers. You can post here, so you can, if you want to request anything in specific, if you want to criticize the fact that something went wrong, you can put that here. If you want to show off what you've done, or you want to say good things, which I appreciate, you can also put those here as well. Now I'm going ahead and back reading so I can see what the questions are. Can you make objects that attract or repel a player object? Yes. I mean, it is general vector maths, but you need a target. You need some way of grabbing a target, and then you need then you can just add force to it. Trying to think if we could come up with a good example. Without writing some really crazy script. No, I don't want that. No, this is going to be a bit of a cheat, but let's see if I can do this. I'm going to do this by turning the script and then using its transform forward. And I may fail, but you'll get an idea of what I want to do here. A little bit tired today, I will admit. So let's say we have a reference to our player. So we have a public game object reference to the player. And then in fixed update, because this is a physics code, we're going to say if the distance to the player. So if we want to vector3.distance, and to find out more about vector3.distance, let's take a look at it. So if the distance, we're given the two objects, A and B. So if the vector3.distance between this transform position and the player's transform position is less than, push distance. So we need to create a public float push distance. So we're saying if we're inside the push distance, let's just you could probably do something with the closer you get, the harder you push. Then you could say something like, I'm just going to add force. I'm going to add force up because I don't want to get into transforming direction right now. And then, so let's just say this will be amusing. We want to take the player's rigid body, and we want to add force. Vector3 dot up times up force. It's a bit silly, but you're going to get the idea. I mean, you could public float up force. Oh, okie dokie. That's fine. And let's look at our cylinder. So our push distance, let's make that 1. An up force of 1 as well. And then we also need to player reference. Save, play. That's not much of an up. Let's give it bigger up force. But see, this is the advantage of having these exposed. Let's give it an up force of 10. Because we've exposed that value, we don't have to go back in. It's still not doing much. Push distance of 100. It's not working. I've done something wrong. This is vector 3 distance is less than push distance. So if the distance between the transform position, the player's transform position, both vector 3s is less than our push distance is 1. We should be, if we're less than 1, go pushing upwards. Fixed update. If vector 3 distance, transform position. Let me just make sure, because sometimes you just don't get enough force and you don't see it. But I would expect 1,000 to be up. Let's debug this. Where have we done something wrong? We can play debugging here. Debug.log, you know, here. So this will tell me if it's ever getting called. So we're never calling this. Oh, I know why. It's coming from the center of the transform. And the transform is 1 unit all the way around. So we can't get close enough to the center of this unless we make this bigger. Means we're never going to be, oh, there we go. See, that's the fun thing about gameplay. So is that running through the logic? Logic's fine. What was the difference is that this is a 1 unit in diameter space. So my transform is also 1 unit diameter. So if they're pushing up against each other, their transforms are gonna be at least, because of diameter or radius, gonna be at least a unit apart. So there we go. There we go. Then we can, so this is, you know, something a little bit silly, but you know, just because I don't want to get into the point of transforming points, is you can get to a point where you'd need to figure out which way to thrust it, but you can, by looking at the difference in direction of the two objects, push straight along the vector that's the difference between the two, so it will never, so you'll always be pushing away from it. Silly. Sorry that took so long. Zuriel, you still around? Cool. Almost. I've very, very rarely had 100 people in this class, and you need to have 100 people in the class to be able to have no rooms. So you can, no sheets. You can definitely, you can guarantee you'll get a seat. Jill Robbie, thank you. You've gone. I appreciate it. Whoops. Lost you. Raphael, I will dump the classes. I don't know if you saw that. I will dump all seats that are no-shows 10 minutes before class. So you won't see register until 10 minutes before class. You need to come to the live training sessions. You need to come here 10 minutes, 5 minutes before class, probably safer, and then I will dump them, usually 10 minutes out, and you should be able to get straight in. Jolly American, come again. You can come for the 102 tomorrow, and then if you really feel like you need to, you can retake 101. There's always something to learn, but definitely if you're comfortable, move forward. Hi, Haim, we will be adding new videos as soon as possible. It's just going to take us a while. Thank you, Zerkiel, that the learn section is robust and it should get robuster. Here's a good word for you, robuster. More robust. Is there a link to a recording of this video? No, Adam, we're not recording these because since I do them again every week, these are not persistent materials. All of the persistent material is on the website, though I'm working on putting the rollerball up onto the Learn site as a mini game, as an assignment. Again, how do I register? Register on the day. No shows will be removed 5 to 10 minutes before class starts. Will the quick question about the triggers earlier? Can the trigger be based on player's progress or how the player is doing? Yeah, it's just logic. In one sense, I don't know what's up with you. Take a look at some of the code that we've written with player controller. If the count is greater than or equal to 12, then print me a label. On trigger enter, if the other game object.tag is pickup. So I mean, I could create another pickup here and then change its tag to finish. I hit play. Whether I can hit it before bumping into the zone of repulsion, but I'm just passing right through it. Let's turn off our repulsion zone here. And I can do that by taking the cylinder and just disabling that script. Oops, play. And you can see I'm not picking up this object. I'm just rolling through it because its pickup is not tagged. So you just need to come up with logic. So, how about this with the pickup? If other.gameObject.tag is pickup, let's put it on another one. Let's actually create this new game object. Let's create a new game object. Let's do it on our cylinder. And let's tag this one cylinder. Let's copy this. And then in our player controller, we're looking at our pickup. So if other.gameObject.tag is the same as cylinder and count is greater than or equal to 5. So this is a complex if statement. Then we can do the other.gameObject.set active false. So now I have to have picked up 5 units, and then I should be able to pick up the cylinder. Let's hit play. And if I try to pick up the cylinder, oh, it's not going to be a trigger. I have to make that a trigger as well. Sorry, that's just got a normal collider on it. So that cylinder also has to be a trigger. Otherwise, we don't get on trigger enter. Or if I want to bounce off of it, I can make that a trigger. And let's copy this into, this is the other way of doing it, on collision enter. I don't think I have to get the collision info. On collision enter, it gives us slightly more information. Gives us collision information, which I can still say the other, but I need collision information. That's what I'm looking for. Collision other. Does that fly? That flies. So I bounce into this one, bunk, nothing happens. 1, 2, 3, 4, 5. I fail miserably. Oh, did we not set the tag? Did we set the tag? Untagged cylinder. There we go. There we go. 1, 2, 3, 4, 5. We're more than 5. Bunk. And we pick that up. And notice we bounced off of it, which is why we don't want to do that. So when you're dealing with triggers and that sort of stuff, you also need to, you can put your logic on the inside of your, like here we get on collision enter. And if the relative velocity is greater than a certain value, then we play our collision audio. Bang. Is it easier starting with 2D games, Zapper? It's different. You need some different things to consider. I actually think not. I think that it's probably easier with 3D games just because they are an analogy that we're more used to. And you can make what's called a 2.5D game, which is what we're doing tomorrow, where we're using 3D objects, but we're playing it like a 2D game. So why don't we talk about this tomorrow if you come tomorrow after we make the little quick mini game? Is there a way to use languages other than the ones supported in Unity? If you have Unity Pro, you can write plugins in other languages. An example would be a C++ plugin for normal games, or say an Objective-C plugin for an iPhone game, and then you can access that using Unity Pro because you can use plugins. But it's not like you can't just simply ignore C#, JavaScript, or Boo and just say you want to script Unity in Lua. Though it's a bit of a lie because I think some people have figured out a way to use Lua with Unity using the Lua library. You'd have to look around because I thought somebody had solved it on a very basic rudimentary level, but you're doing a bit of an end run. These are all relatively old. I would suggest using that custom search engine and looking at Lua Unity if you really were interested in Lua per se. But in general, the languages are C#, Boo, and Unity's JavaScript. P-Bud, is it possible to have several people work in the same project at the same time? Yes, there are some tricks. I do think that using version control of some sort helps because you can deal with repositories. Also, it helps that you don't work in the same scene. An example of something that you could do, hold on a second. Is if you're working in a prefab and you're changing prefabs, you don't affect the scene. One of the problems you can have, especially with version control, if you get two people working in the same scene, then you have to find some way to resolve conflict. But if you save something like, say, your player as a prefab, and then your level designer is going through your level and creating the pickups and putting the pickups down and figuring out where the cylinder is going to go, you can open the prefab of the player. You can create a new scene and call this one in your version. You're going to save this, and this is going to be player editor. And then you can put the player prefab in here, and you can be tweaking values and hitting apply. And since this is a prefab, you'll be updating the prefab, and in the minigame scene, that player just gets updated without creating a conflict, unless someone starts editing the player. So yes, you can have multiple people working on things. The best thing to do is try not to work in the same scene at the same time, and to have people working on prefabs or rewriting scripts separate from the level designer who's working on the scene. Abacus, right. What's not working? Is it the fact that the beads aren't working on the wire? What's not working about your abacus? Seneth, hold on a second about the shadow thing. Oh, bother. That's not what I wanted. Two seconds. Not want to do that. Two seconds. This internet is incredibly slow today. I'm trying to answer your question. I haven't found it yet. All right, I don't actually have the answer I want to find, but can we leave it at Unity often rolls pro features to Unity free at a regular basis? And we'll leave it at that until I can find the actual answer. Videos are not being recorded. Streamlining common tasks. Plugins that I like, I use NGUI and EasyGUI when doing sprite UIs. I think that EasyGUI is still technically more powerful. NGUI is a little bit easier to use. Your choice. I use Script Inspector 2. I don't, but many people use iTween for tweening animation. What else do I have that I use? And these are very personal categories. I use for Script Inspector. I use Script Inspector internally for if I want to do writing, editing inside Unity. I'm trying to think of what else is in my download box. Fussed with a lot of these different things. Autopilot, if you're going for Unity, if you're using Unity through Unity iOS and you want to go to testflightapp.com, Autopilot can streamline that extremely well. Behave is pretty good for behavior trees. Um, Gem Shader, that's very old. That's very, very old, but still works. These are just things that I have in my personal things. Mechanim, if you get a chance to use Mechanim, definitely do that. Script Inspector 2. Smooth Moves for 2D animation. I like it's bone animation. You could also use Spine. Spine is also very good. Strumpy Shader Editor. If you're editing shaders that are not DX11 shaders and you don't want to get into writing shader code, Strumpy Shader Editor is very good for getting for doing that sort of thing. Unide is also the other in-app IDE. Just started playing with voxel stuff. I haven't had a really chance to play with that a lot. So those are the things that I have in my setup. I'm trying to think of some of the other ones that I've used. I hope that helps. Shadows, if you don't get real-time shadows, blob shadows and projectors are the two most standard ways of doing it. You can get projectors from going to assets, import package projectors. Now, this is a very stale project that I've done a long time ago. The thing I found out about projectors, especially going to iOS. Now, this game that you're looking at, even though this is the web player, I did get working on iPhone 1. The very first generation of iPhone, and you can see that she has a shadow and it sticks to the ground. That's a projector shadow, and you can look at projectors. Now look at the spiders down here, and they look like they have some mild shadowing with them, but they aren't. This shadow is, and the ring around them is actually a sprite, because I found out that for the iPhone 1 projectors, which are not a bad thing like this, you could use projectors for this on the creature. Let's see if I can grab its attention. Hello, come after me. You can see how this ring is really a sprite. And so this is a sprite that it digs into the terrain, whereas the blob shadow on Penelope is being projected down on the surface. The thing is it requires a pass, an animation pass every time you do it. You have to re-render the scene. Oh, that didn't kill you. Whoops. That will. So when you're dealing with something that draw calls are a problem, you have big issues with and transparency. You don't want to be re-rendering your scene again and again and again. So if you're dealing with, it really depends upon your platform. I could put projectors in it all day long if you didn't want to go to mobiles. Mobiles are also becoming a lot faster. Like I said, this was designed for iPhone 1. So now with people really not developing for much less than iPhone 3GS or 4, you may have a lot more versatility. Okay, good night. Lots of people who have left. Can't figure out how to get the camera to rotate with the ball only on the y-axis to further represent following the ball. It's difficult in this particular case. because the ball is rotating on all axes. So how would I do that with a rotating ball without getting very, very tricky? You have to sort of define where you want your forward point to be. And part of what we're doing here specifically is using a physics ball where it's rotating because of physics. And I don't have to worry about its actual rotation because I can simply add force in a direction. Let me just turn off that maximize on play. And it rotates, but you can see that there's no real transform forward. Technically, the blue arrow is forward if I wanted to get to transform forward. So I'd have to have some way of calculating what direction I'm moving. I would probably have a tendency to want to cheat and use another game object that was oriented based on my transform. But this really isn't the type of game that you'd want to have your ball follow you around. I mean, there is, at one point they had a rollerball script that you moved the transform and then rolled the ball. Let's see if I can find that rollerball script. It's a different way of solving it. Now, where is this from? This was actually from iPhone standard assets way back a long time ago. Let me just copy this over for you. And the thing about this is you're calculating the size of the ball, and you have to realize that this has got old acceleration stuff, but the idea is that however you move it, and this rigid body add force is in the wrong place entirely. So this is not fantastic code. I can't believe that this is actually was a standard asset 3 or 4 years ago. But the idea is that you're moving your, you're adding force, but you're also rotating based on the size. And you can start to use this to start picking apart how you'd move stuff. So the idea is that you could probably move your transform and then roll the ball around it, and then you'd move your camera related to your transform. The other thing is, I mean, you could PM me and I could come up with a more elegant solution to that. We can talk, and Gwez, we can talk about that in Q&A tomorrow as well. But that's not going to be in the content of class. Again, tomorrow's class is really tightly scripted to get a whole game done in 4 hours. Yes, you can set a tag through a script. You can just say, you know, I mean, this will be silly, but look at this. Other.gameObject.tag equals, not comparatively, Captain Kirk. Now this will be on the deactivated game object. So remember, there's our cylinder. It's called cylinder. Now we have to pick up 5 game objects. What bounce? 2, 0, 3, 4, 5. Bonk. Oh, not defined. You have to set it up first. Sorry, that was me being silly. You can set up that Captain Kirk. You can make it Captain Kirk, but we still have to have that tag existing because the tags have to be set up in the tag manager. Now let's try this again. So 1, 2, 3, 4, 5. Bunk. So it goes away, and now we can see that that tag is now set to Captain Kirk. The abacus doesn't respect your colliders. And most of the time they don't respect the laws of physics. Well, humph, how are you moving them? Are you moving them with add force, or are you moving them with position, with transform position? What's my take on Playmaker? I need to use it, which I haven't, because I generally have been just haven't used node-based visual scripting editors because I don't know how to debug them. And I've never had a need for them, but I should probably learn one just so I can answer that. Darren, you were saying about a hidden object. Yeah, but the thing is the hidden object's rotation you need to eliminate, which you could do with script. So you could have a null object in the center of the ball. But where it becomes tricky is if you want the camera to always be behind the force of the ball. Like an example being, I'm now going to roll this ball. Whoops, I'm flying. And I'm moving in this direction, but frame selected. I need the camera would now should be back here somewhere. So I need to know the direction in sort of in world space of where the ball is moving, and then I have to set the camera to a position behind it, facing that direction, and yet I either have to do that with a null. I mean, one way that you could do that is, yes, you could put a null object inside the, an empty game object inside the player. And that gives us the center point, but you might as well get that from the center point of the player. I need to calculate its motion through world space to know which direction it's going. If that makes sense. And that's what gets kind of difficult. And I have to actually wrap my head around it and think about it, because you can transform direction and you can transform. There's code inside the API for taking direction and taking position, and then you can transform the point to world space, and you can transform you can change it around, so you can get that information, but it's not something I can really easily do live without having to think about it, especially not at 1 in the morning. Are there any advantages of using sprite sheets? Or atlases? Yes. I would use atlases for textures. I would use atlases for some sprites. If I was using 2D animation, though, I would use bones. I would use either skin mesh renderers and bones, or I would use 2D bone animation and then sprite atlases for that as well. But I wouldn't be cycling through my sprites for 2D animation. And partly what I'm going to do is send you to this Kickstarter, and this will be old just because I know they've got the a good video on this. And this was funded quite a bit. Oh, let's see if we can get to it. Come on, you gonna let me? It's too old now. Nope, there we go. Yes, they wanted 12 grand. They got 67.5. Watch the video on this about bone animation, and this is true for both spine and smooth moves, and it'll show you why you want to be using bone animation in the 2D context rather than sprite sheets. An atlas is recommended for 2D animation, but I wouldn't go through a sprite sheet where you're cycling through pre-built animation. And I'll cycle through it, which is basically, let's see if I can find the section. You know, you can see that, I don't know if you can see this, where you're essentially doing the same thing that you want with where you've got bones, except you're using it in 2D. And also, just like Mechanim is allowing you to repurpose stuff, you can change your sprite sheets and keep the same animations and the same bones. I don't really want to hear him talk. You can find out about that on your own.
Animation in spine is done by attaching images to a skeleton. Then the bones are animated and the images move with them. This has many benefits over traditional animation. First, art is often the hardest part of building a game. Using spine means much less art is required. Creating animations becomes so fast and easy, even programmers can do it. Skeletal animations are very small because only the bone positions need to be stored. Games can easily...
So you get the idea. You're still using texture atlases, but you're not actually running through a sprite sheet. You get higher resolution, you get frame rate independence, all sorts of good stuff. And I'd say the two I would look at would be Spine, which is this one, and Smooth Moves. Smooth Moves is Unity only. Spine, the whole point to this initiative was, and I think they've succeeded, you'd have to check up on them, was that they had the bone animation system, but wanted to port it to a bunch of different game engines, including Unity. Let's see if I can find it. Sorry, I'm zipping through. This won't be any good for you, but I know what I'm looking for. Yes. So they're looking for Unity 2D, Cocos 2D, and Cody. But this you need Futile or 2D Toolkit to use it. Whereas, and this may have changed because I think one of the stretch goals was just to use it directly. But if you did this through Smooth Moves, you don't have to go through one of the other toolkits. Yes, you could animate your own shadow. Yes, we'll be using 3D meshes, Joel, tomorrow. Okay, German. Rigid body. The balls are not using a script, just the default rigid body settings of drag, angular drag, and mass. You know what, German, can you send me your project and let me just have a take a look at it to e-learning? It just may be a little bit of a fussiness. Changing scenes, you use application load level. On collision enter, let's change this to Captain Kirk, and then let's give it an application load level. What did we call that other game? Demo scene. Demo scene. So when we bump into the cylinder, we'll load demo scene. The first thing you need to do is make sure that you have both demo scene and minigame loaded in your build settings. Otherwise, you can't access them. So we're doing on collision enter, and let's just make this after 1. And then we will bump into it, and that bumping into it will load our demo scene. So it's application, load level, the name of the scene. If it's loaded in our build settings, we can hit play. Get rid of that, please. Let's pick up a unit, boink, and then poing, we've loaded the level. For 2D animation, I would say an atlas is recommended for making your character, so your whole character is one material, but that you don't run those little tiny sprites. You don't run pre-drawn sprites. Can you reference an object or component on an object that is located in another scene? No. You can't get a hold of things that are in another scene. You can leave things, you can make prefabs that you can use in both scenes, but you can't look at an instance. One instance in one scene cannot access an instance in another scene. And frankly, it doesn't really make sense. No, the question of depends how you move them, German. Is this for touch device or is this for a mouse-based device? What's the best way to store persistent data, such as dialogues or quests? Scriptable objects is not a bad way of doing it. And also, it depends how you want to do this. Scriptable objects are really for saving things within your game. This would be where I would put quest data and inventory data because it's an object that is used to handle data. It's an asset. It stays in your assets directory. You can really only make them in code. I have an example that you can look at. And there's sort of two examples in this. And one of them shows sort of a basic inventory. All right, I think we need to give you the one with the. Let me just. I think that link isn't going to work because I think that Adobe Connect hates spaces and buggers them up. So let me get the other one. There we go. But an example is you can do this. Make a little inventory item, and you can, add items, give them a texture, give them a name. You can delete items, set their values. And this is all done inside, even though we're doing editor scripting. When I get done, it's like making a little database. I can have all of my items in my game, and it's being saved inside a scriptable object. So it becomes my little database inside a scriptable object. Now, if you're talking about saving data, like saving scenes between one session and another, I would definitely go back to the asset store and look at save scenes and look at some of the choices. This one is good and free. It comes highly recommended. I will admit that he seems to be slightly less active recently than he has been in the past, but it still comes up on one of the highly rated ones, and it is free. But I would look at somebody else who's come up with a save game system, because it has to do with serializing your assets and saving them to a file. Yeah, when it comes to changing the scenes, you just have to put that in. Um, uh, right now we have application load level demo scene. Well, you put something here. Maybe what you want to do is not do that, but call start coroutine load my level, and then you'd create my enumerator load my level, and then you could do something like yield return new, wait for seconds, 1.5, and then put in some transition where you fade something in or fade something out. I mean, this is just a wait uh, instruction, but you just need to build all of that stuff. Just gets built into code that you want it to be. So now I bump into this, and then 1.5 seconds later, I load my scene. So it's just a question of how you want to associate your code. Yeah, send me the project. Let me take a look at it, German, because it's sort of, I'm not quite sure what the problem is. And essentially, you need some way to grab that input to move those, um, uh, move the beads. And then the question is I don't know if you want to be able to take your device and shake it, have all the beads go crazy. But yeah, let me see what your implementation is, and I'll see what I can suggest. The editor extension, Conrad, was just a way of showing. There's two examples on how you could use scriptable objects, and the editor extension is just a suggestion. But there are other ways. I've seen examples where someone made a ghost car, and the ghost car was saved. Every frame's position and time.delta time was saved in a scriptable object. So there are ways to just save data in this little package, and I just came up with two quick ideas. Um, I just found it convenient, partly because I'd done it before in a similar but different manner, to save the information in a file. But scriptable objects are just ways of saving data. And if I was to make an inventory that with a bunch of items, that's where I'd save it. And why not build a front end for it using editor scripting? Averon, as far as I know, you could look up localization. I believe all of that stuff is handled third party. Other people seem to be doing it quite a bit, as a matter of fact. Looking at our docs. No, you can grab it. But you'd need to do that. You can grab the system language to help you set your localization, but it looks like that's something you need to set. All right. Well, it is midnight, or it is 1 a.m., so I should probably sign off, and I'll see most of you tomorrow. Thanks for coming. And tomorrow we'll make a game. Oh gosh, don't yawn. Yeah, I think I might. Actually, it's probably going to be a shot of whiskey. But then I need to go to bed because I've got to take my son to school in the morning. So yeah, school in the morning. So I've got to be up. Let me tell you, it's not a cool lecture here right now because it's the hottest I think Britain has been in some astronomically long time. It has not cooled down yet. But it was fun. All right. I'm going to sign off. I'm going to go straight to sign off. Usually I'll leave this open for a little bit, and then let you guys cool down and show something neat. But I need to go to bed, so I'm just going to sign off and say goodnight. Thank you very much.